Hello, everyone. Yes, your eyes are not deceiving you. The quality of the stream is hopefully better. Um, I set it up so that now you can see in 1080p instead of 720p, which it was whatever it was yesterday. Everything has been set up. We have done it. The stream that yesterday was failing is hopefully today succeeding. We have average and pretty stable 9,000 kbps, which yesterday was a complete nightmare. But yesterday is a different day. Today is a different day from yesterday, which means this is a different stream, which means the settings are different, which means this is going to be a different experience, which means, yeah. Anyways, so today, we're going to keep working on the stuff we've been working on, especially what we left for later yesterday. Specifically, we are writing malloc, and malloc is funny guy. You know, that's the way I would describe malloc if malloc was a person. Um, so we have yet to tackle some of the problems and like the specific sort of things that may make malloc difficult. And yeah, I mean, I guess we'll just I don't know. Let's just jump straight to it. Um, yeah, feel free to ask any questions. Feel free to suggest something we should do. Maybe you have a topic of conversation. Like we're saying, like, coding today. I don't want to watch that much. Um, you know, suggest something in the chat, like, or like ask questions, interact with others, etc. And let's get started. Okay. Also, let me know if the stream ever gets laggy. I'm gonna leave it on you to tell me if it gets laggy because currently I cannot see my own stream. The reason for that is the fact that when I enable the preview, it gets unbearably slow. So I feel that is one of the problems, and that is what has allowed me to get it to be like smooth like butter. So you guys are gonna have to tell me when the stream gets it's like that, right? So let's go to the coding scene. And right now you should be seeing all of the code that we were looking at yesterday. So if you remember correctly, let's make like a little recap. We're writing the malloc function, right? And so for malloc, we decided that we were going to perform sort of a lazy initial allocation. That is, if the user never wants to use the heap, then there is no reason why we should be putting memory in the heap in the first place, right? For that reason, we decided to perform a lazy allocation, and by that we mean in the first call to malloc, we're going to initialize everything for our program, okay? So in our first call to malloc, which is enclosed by this if, we're going to introduce some padding to make everything 8-byte aligned. Then we're going to allocate the ghost node, that is our red black tree. So I would rather say we refer to this as the ghost node. It is sort of a convention here in our stream. We should change its name to be like, the red black tree. I'll leave it as the ghost node because many of us know it as that, the ghost node, because of the way I've been talking about it. And yeah, so basically we create space for the ghost node. The ghost node being sort of the representation of a red black tree, where we set it to be that arbitrary sort of root, that ghost node. And finally, we say that the root of the red black tree is null. Perfect. Now, if the call to malloc is, or sort of after this is done when it comes to the first call, or if the call to malloc is not a first call, then we start here, right? First, we would need to search our red black tree for our free block. So we perform an arbitrary find to find in this arbitrary the size that we want. Size is the thing that the user passed to us. So if we have something that can accommodate that request, then we're just going to return exactly that to the user. Otherwise, we're going to have to go through a little bit of a hellish journey, because if there is no free block, it means that we now need to expand the heap. So it becomes this sort of odyssey because of a small optimization that we were thinking about yesterday, and it's the following, right? It's whatever's depicted here. So if this is our memory, and the user has already allocated, these first two blocks of memory that have a line over them, and then they ask us to allocate 24 bytes. We don't really have 24 bytes, right? Currently, as it stands, imagine each of these little blocks is a 4 byte block or represents 4 bytes. As it stands, we have 12. 1, 2, 3, right? 12 that are free. 12 bytes free. So we cannot accommodate for 24. One could say naively, okay, let's just create a new block that is 24 bytes long and just give it to the user. But you'd be thinking wrong. An optimization we can apply actually is, since we already have 12 bytes here, we just expand the heap by 12 more. In that way, we can expand the heap by sort of a non-unnecessary amount, right? Sort of taking advantage of whatever we have already allocated. And so with this in mind, we are going to be able to sort of optimize our space usage and all of that. And the way that looks in code is as follows. So first, we need to see if that last block is free, right? So the last block footer, we go there and we try to find the footer of the last block. Then from that, we compute the position of the last block, or sort of the pointer to where the last block starts. Then we compute the block size of whatever we're going, or sort of this new block that we want now to accommodate the user's request. And then we're going to say, well, I'm going to need at most whatever this block size is, right? To accommodate the block size. Makes sense. But if the last block is free, I could use the space that it hasn't yet allocated and account or sort of count on it when it comes to the space I need. So I subtract from the needed space the space I can reuse from that last block. And finally, we're going to say, well, we want to expand the heap by this amount. What amount? Well, yesterday we were talking about this and like whether or not we wanted to use some heuristics in order to play around with how to expand the heap. And we ended up determining that it would be ideal to have some sort of expansion factor. And by that, I mean, once we need to grow the heap, we're going to, instead of growing it by the amount, exactly the amount we need, grow it by some factor of its current size. So for example, 30% of its current size or 50% of its current size or its current size, right? So multiply its size by 2 or multiply its size by 1.3 and so on and so on and so on. Why? Because if the user expands the heap now, it's kind of likely that they're going to need sort of more space in the future. And what this entails is the fact that if we are able to predict this behavior with this sort of heuristic where we expand by a certain factor rather than by exactly what we need, we're going to be able to avoid not as many syscalls as possible, but a lot of system calls, right? And remember, system calls are expensive when it comes to speed, right? So what we're going to do is our expansion size is going to be the max between the heap times its expansion factor or the needed space. It could just be the case that we just need an enormous amount of memory to expand the heap by, in which case we can, like, it's like a big enough number that it's bigger than the expansion factor. So we just make it be that number because it's already pretty huge. And after this, we simply expand the heap by that. Now, we may have a problem, right? And that problem is the fact that we want every single address, or not every single address, but every single block address to be 8 byte aligned. And what that means is that we are somehow going to need to align the space that we are going to allocate. I'm not sure if I am explaining myself correctly, but of this space that we're adding, we just have to make sure that is 8 byte aligned. Okay? Now, we don't have to sort of worry about it that much. And by that I mean we have already guaranteed that any insertion of any block is going to leave our heap 8 byte aligned. Which means that whenever I try to insert a new block, that thing is going to be 8 byte aligned too. And the new block, I know, I'm guaranteed that thing is going to be 8 byte aligned too. So when we allocate new space, even though it may not be a multiple of 8 or something like that, it doesn't really matter. Because in the end, what I'm going to do is put another block here. And the previous blocks and the way we have arranged our memory guarantees that on an insertion, we're going to be 8 byte aligned, independent of the amount of space we have left. So these are things that seem rather disconnected from each other. And for that reason, we are going to decide to simply just not align the amount of space by which we expand the heap, right? So in this scenario, I think we are good to go. I think we can just code it like this. I am nonetheless going to add a little file. Maybe I'll call it common.h. And I just want to declare like the max macro because currently it is not, declare, define. Define the max macro because currently there is no such thing. And the way we can define it is simply, well, if x is greater than y, then choose x. Otherwise, choose y. Right? So I think this is okay. We don't know what this may be, so let's include parentheses around it. And then same here, and then same here, and then same here. Perfect. All right. Now we're gonna go over here and we can, we have an error. Let's see. Oh, that's fine. And we can include sort of the common header, right? There's really no sort of, at least from what we looked at yesterday, there's no max macro predefined or function for that matter. And so we have to create our own, but that's completely okay, right? So here we have it. Now, remember that this expansion factor is a double. And this guy is a size t. We need to make this so that it rounds up in relation to what we need, although, see, I think this is fine. Yeah, I don't think the compiler is going to complain. I think, just to be safe, right? Let's just convert this to Unit 32 once it's done. Perfect. All right, and then we expanded by that much. So we determined that we don't really need the alignment. Let's just leave it like that. Now, let's see what we need. So there's something that we have to have in mind. And it's the fact that after we perform this sort of expansion, assuming that the last block is free, that block belonged to the binary search tree. But now that block is longer, right? So we need to update the block and reinsert it into the binary tree, into the red black tree. So what I mean by update the block, as you can see, currently, we have only expanded the heap by that given amount. So that is almost as if we had this, right? We have created this little guy. But we have not created yet, or we have not yet modified the number that's here. This 12, once it's expanded, should instead be a 24. So we need to perform that modification. Not only that, but the red-black tree is pointing at this block because it was the last block, it's all it knows. It was, sorry, pointing at this block, but that block is no longer just 12, it's 24. So it should be pointing to like the entire thing, right? And the fact that the size increased means that this block could take a different position inside the binary, the red-black tree. So yeah, if we were to not expand with an expansion factor and instead only by the needed space, then we would know for a fact that this would be the smallest node that exists, since nobody could really accommodate further requests. Well, actually, no. I am completely wrong on that. Do not quote me on that. That was a really bad conclusion. We're not guaranteed anything. Okay? So we need to update this block and reinsert it into the binary search, into the red-black tree. So to update the block, and by that I just mean its size, we're going to have to do a couple of things. So let's see. The last block, right? We need to not only interpret this as a block pointer, but also change its size to something that actually reflects the actual size. So it would have size, expansion size, so however many bytes we added, plus the block's current size. So block size of that same block, right? So the block size of that block, which should be whatever was allocated before, right? And oh, Fish Retina, hello. Welcome to the stream. Glad you're watching, hanging out. The expansion factor is what we decide, like, sort of, is our expression of this heuristic that I'm pretty sure you've seen with vectors, where whenever you sort of exceed the size of the vector doesn't expand itself by the exact amount that you need it to expand by. Say, for example, I don't know, right? We have these original 12 bytes, 12 byte block over here. And if we say, well, we need to expand the heap, right, to accommodate for a guy that's 24 wide, we're not going to expand by exactly the amount we need. We're going to expand the heap by a given factor. In the case of vectors in C++, I remember it's something like 2. So you multiply the size of the vector by 2. And that is so that pushback becomes like an amortized of one operation. And so that you don't have to perform as many system calls in the case of the heap as you would need in the other case, where you expand the heap by the exact amount you need it. So it's just a heuristic to save some system calls. And the expansion factor that we currently have, I determined it to be 0.35. That is like, because we're not specifying a multiplier, we're specifying like the percentage by when we want to increase it. So 0.35 would be increase the heap size by 35%. That is perhaps a little conservative. If we want to increase the heap size by the amount it currently is, that is double its size, it would be a 1, and so on and so on. So currently I just have 35 for no specific reason, to be completely honest. Yesterday on stream, we were all talking and ended up like picking that number, the 8 people that were there. And yeah, so that's the expansion factor. And with that expansion factor in mind, we need to set the size of this block that we just expanded, right? Because we added more bytes at the end of the heap. So this guy needs to realize, well, I'm no longer 12, right? I'm more 28 or 24 or whatever its new size is. 24 in this case. Actually, it's 28. Now it's 24. Perfect. So what we're going to do is we're going to go convert this to a block pointer. Ooh, convert it to a block pointer, the last block, access its size, and make its size equal to the size by which we expanded things, right? Minus the footer that you're going to have to account for, right? So let me see. Your current size would be the size you already had plus the size that was added at the end of the heap minus whatever you're going to need to allocate your footer. So currently here in the drawing, it would be the size you were before. That's this. Let me actually put them in parallel. There you go, right? The size you were before, which would be this guy, BK size. BK size. BK size. Plus the expansion size, which was this guy. So that's expansion size. So expansion, XP, and then size, right? Size. Okay. Okay, there you go. Expansion size. But remember, our blocks in memory look something like this, right? They look like size, left, right, parent, color, user data, and then size at the end to facilitate coalescing between blocks, which means that we also need to include that footer in our new block. So it's gonna live in this last 4 bytes, which means we have to subtract whatever the footer is. So now we subtract the footer. And that should give us what we need. It is currently complaining. Let's see what it is. Expression must be of modifiable value. Oh, I think it is for the fact that currently in our struct for the block header, we have to find size as constant. Yeah. So let me just remove that. Because now we have finished the red black tree. Now we're able to sort of be very conscious about the fact that we shouldn't be modifying the size unless we know what we're actually doing. Let me go back to memory.c. Here, there you go. So we have updated the block size, right, by that much. And now we need to update the footer of the block. And that thing we have over here, right? Last block footer. And so for that footer, I think we can simply set size to be the same thing. So I'm just gonna access whatever the value we just set was. Right? Perfect. So here in the last block footer, I'm pretty sure that the footer has the size also defined as const. Yeah, just because we didn't want to make mistakes while we were writing a different piece of code. And so now that we actually have the freedom to modify the size of the block, we are able to do that. I think this is correct and decent enough. Yeah, we can fly with this. So the question really is, are we... Let me think, because this is the thing. So previously, before we performed the expansion, right, this block had a header, or sorry, had a footer. So what that means is there was a guy here called 12, while the header was also 12. And when we expanded, we need to account for the fact that now we can write over this address because the footer has moved. So let me see if in our calculations we had that in mind. So we go to the last box footer. We get to the last block, so here we are, last block's footer. Then we get to the last block. Oh, sorry. This is before the expansion, so forget about this. And bring this guy back. 12. There you go. There you go. Perfect, perfect. So what we do is we say, okay, go to the last block's footer. Now you know what the size is. So now you know by how much you need to jump back in order to get to the beginning of the block. And once this happens, you're able to calculate, okay, from the new block, what is the size that I want for it? How much space do I need to allocate the new block that I'm about to insert? And that's block size. We account for the header of the block, the size, and the footer of that block. Perfect. Now, we're going to need at most this much space, but there is a thing, right? We don't really need to allocate size or to use space for the header because we're going to reuse the header that the block at the end needed. But that is something we are not guaranteed if this last block is allocated. So let's wait. So you're going to need at most block size many bytes. Now, if the last block is free, then the amount of space we can reuse is the last block's footer. So the size of that, which should be this, right? This size, plus the size of the block's footer. So we can also use this space over here. And not only that, but, and we completely forgot for absolutely no reason, we can also reuse the header of the block, right? So that's the amount of space we can reuse. And now we're going to say, well, for the needed space, just subtract the reusable space. Now we're going to say, finally, the expansion size is going to be this calculation that we made. And then finally, we expand the heap by that much. Oh, new message said, okay, Fish Retina, what is the header of a block? Hello. Okay, so I think it's better if I think I have a little drawing here. There you go. So this is a block. Basically, we have memory, right? Oh my god, dude, why is the why is the size of this thing so small? Let me see where I can access the setting to make this a little bit thicker. Oh, wait, where is it? There you go. Here it is. So basically, what we have right here is this. Memory in our computers, as you may already know, is simply you can think of it as like a set of cells, right? Little block cells, each storing a byte of information. So a group of 8 zeros and ones. And I am not very good at drawing, so I'm just gonna copy and paste the same line I've been doing so that we can create a good model of memory. Over here. Oh wait, I think I had a drawing before. Yeah, we had this guy. So let me just erase all of these annotations and we can use that. I don't want to erase the actual cells. Okay, there you go. So we have this, right? Our memory in a computer, you can think of it as a strip of these little blocks, each of them representing sort of 1 byte, right? For the sake of simplicity, we're going to, or not the simplicity, but for the sake of fitting everything into a drawing, you can think of this as having 4 bytes, right? One of these guys contains 4 bytes. So a set of 3 of those is going to be 12 bytes. Memory in your computer, once again, is just a strip. Each of these blocks contains 4 bytes. And what happens is the programmer is going to, as they go through the program, request for memory, right? Maybe they need to allocate some sort of object, they need to load in text, they need to load in an image. And what that's going to cause is somebody has to give that memory to them. That somebody is us. Now, memory is just lying there in your computer. So you could just go and take it, right? You could just say like, oh, I want these cells for me, right? The problem is other programs in your computer will not be able to know that, right? They don't know who is using what. For that reason, every program is given a little space of memory for themselves. That space is called the heap. So every program has a heap. And they can use that little section of memory that's reserved for them to store whatever they want. Now, think of this little strip as the heap for our program, right? We're free to do whatever we want with this guy. The problem is, during a program's execution, the programmer will create and destroy objects all the time. Maybe they load in an image, and maybe once they're done, they're like, okay, right? The image is occupying all of the memory we have available. So once they're done, and then try to load another one, the program is going to say, oh, no, that's not possible. But the programmer is going to be confused. What do you mean it's not possible? I just loaded an image. The reason is because this programmer put the image they wanted to look at. They put it in memory, but then they didn't free that memory so that another image could take its place, or another text could take its place, etc. So then we enter the operation of what free means. Free is simply saying, given a space in memory, I am going to tell you I don't need it anymore. So we have two basic operations. Malloc, which is memory allocation, which allows you to say, hey, I need 12 bytes, right? 12 bytes of memory to allocate something. So I need 3 of these cells to put some information in it. That's malloc. And you just provide the number of bytes you need. And then there's another guy, which is sort of its companion, which is free, which is used to indicate, oh, this space I asked for before, I don't need it anymore, right? So in this case, if the programmer says something like, oh, please, malloc, sorry, this thing is very small. They call malloc, and then they say 12. So they are like, oh, please give me 12 bytes, right? Then what is going to happen is 12 bytes of the heap are going to be provided to the programmer. Then the programmer says, I don't know, malloc, maybe I'm going to need 24 bytes now. So now a block of 24, so 1, 2, 3, that's 12, and another 12. A block of 24 is going to be provided to the programmer. Then the programmer is going to tell us, well, I don't need the block of 12 anymore. So free 12. They're not going to pass us the number, right? Because there could be many 12 long blocks. We can simply, they're going to pass us something that's called a pointer, but that for now is not that important. Whenever they call free 12, we say, oh, okay, the programmer doesn't need it anymore, right? So then we free it. And if then later in the program they say, oh, I need another block of size 12, so they call malloc 12. Instead of allocating another block here, we can just reuse the space that was recently freed, right? We can just put this here. So those are the two basic operations that we're going to have. Oh, new message in chat. Let's see. AI viewers stream booted. All right, buddy. You are getting banned. Astronomically banned. Thank you. All right. So yeah, those are the two operations, malloc and free. So you're going to hear this throughout the stream a lot. Now, why do we need somebody to manage memory if it seems so simple, why doesn't the programmer just sort of do it themselves? Well, notice that the programmer kinda does it itself. They tell us that they need some amount of memory and they tell us when to free it. The problem comes with this concept of fragmentation. So suppose that the programmer calls, they say malloc 12, malloc 24, and then they say, I don't know, so malloc 12 would be these three, malloc 24 would be these six, and then they ask for, I don't know, malloc, another malloc 12, or well, malloc 8, right? Say they need 8 bytes, so there's going to be 2 of these, right? And now suppose they need now something like malloc 28, right? 28. They need 28 bytes now. As you can see, in our current layout in memory, we don't have enough space for that. So one of the scenarios we'll have to tackle is asking for more memory to the operating system. So we, as the managers of the heap, have to ask the operating system, can you expand the heap a little so that I can suffice the programmer's request? So that could be one scenario. Now, what happens if before asking for the 28, the programmer says, actually, I don't need that block that's 12 bytes wide. So then they free that 12 byte block. The question would be, do we have enough memory to suffice this malloc 28 request? Initially, it may seem like yes. We have 1, 2, 3, 4, 5, 6, and 7 blocks. And 7 times 4, given that each block represents 4 bytes, is 28. But remember, the memory we provide to the programmer needs to be contiguous, right? And so now we have this sort of problem called external fragmentation, where our memory, although present and we may have the amount we need, is like fragmented, right? There's like little bits and pieces of memory scattered everywhere. One of our roles as the allocator is to reduce the possibility for this to happen. So now it's not just like you're going to be very naive and give them whatever block they need, or you're like, oh, a block of 12, I'm just going to expand the heap by size 12 and give them whatever's extra there, right? Now you need to be a little more smart on where you put your information. The programmer, we hopefully can make their life easy so that they can just call these two things, malloc and free, and everything will work smoothly. But we will worry about what's happening behind the scenes. Another thing is that, say the user freed that block of 12, right? And so we're saying, oh, this one here is a block of 12. And this one here is a block of 24. And this one here is a block of 8, right? Suppose now they call free on the 24 block. So they call free and say 24, right? So now we free this. And suppose now that they say, oh, I need to allocate 36 bytes. Do we have enough space to accommodate that request? And the answer is yes. It seems like it, right? The problem is our program doesn't really know that. For the program, which can only look at sort of these numbers, there's a block of 12, there's a block of 24, and there's a block of 8. There's no block of 36 or greater. You see that even though we freed this memory, we didn't update the metadata, right? We didn't keep track of the actual size of the block now. So now, as the memory managers, we also have to be in charge of updating that information so that the allocator can work well. Now, whenever we free the block of 24, we're going to have to detect, is there a free block to my left? If so, let me merge with it. So in the case of 24, it would say, okay, I'm going to merge with the guy that's behind me, and now that's going to be 36. and so on. So a memory allocator is just the guy that's in charge of managing the memory that the programmer may need and of sufficing the programmer's request in the most efficient way possible, both in terms of speed and in terms of memory usage. Because if you want something to manage your memory, it better use not that much memory, and it better be also fast. So yeah, that was. I don't know why I extend myself with the explanation so much. It is a habit I need to change. Um, Most of that was completely unnecessary, but yeah, I don't know. I don't know how how familiar you're with memory allocators. I assume I don't know, a good like a decent explanation would be helpful. But yeah, that's all. So currently, what we're doing is we're designing what malloc is going to do. So whenever the user, that is the programmer, calls malloc, what is it that we as the memory allocator are going to do? Um, Thank you. It was a good explanation. Oh, thank you. Not sure if it passes my standards though. It was too long, but it's okay. It's okay. It's okay. It's over. It's over. So now let's focus on how that looks like in the code. Um, so here we can, well, we, as we were saying, we're doing the lazy initial allocation. Um, let's not focus on this because we looked at this yesterday. Right now, the way it's looking is if the user requests a size, we're going to look among the free blocks that we currently have, those blocks that maybe don't have any information. Um, and, and then and then we're going to search our red black tree, which is the data structure that's going to store sort of where our free blocks are. And it's going to try and find a block that can accommodate that size. If they find a block, that is, if the block they return is not null, then we're just going to give that to the user. But if the red black tree couldn't find a free block, it means that every single piece of memory that we could have used to suffice this request is too small. So now we need to expand the heap more. And so if there is no free block, we're going to span the heap. And this is where the little sort of optimization comes into play, where we say, okay, if the last block is free, maybe we don't need to expand by the full amount. Maybe we can reuse the space of the last block. So we're going to go to the last block, we're going to find it, and we're going to say, okay, this is the amount of space I need, block size. And then store the needed space. If the last block is free, I'm going to see how much of that space I can reuse. And then I'm going to subtract from it, from the needed space, the space I can actually reuse. Then we calculate by how much do we need to expand the heap. We need to expand it by either the expansion factor with the heap size or by the needed space, right? And then we actually expand the heap by calling this function. Finally, we need to, for that block that was there at the end, we need to update its information, telling it it's bigger. So now we convert this to a block pointer, we go to the last block, we access its size, and then we're going to tell it your new size is whatever you had before, plus the amount by which we expanded the heap, minus the sort of the amount you will need to store things inside the footer, right? I think this is correct, question mark, maybe. Let me think. Seems like it is correct. I don't know. Like, honestly, we're just gonna let time tell us. We have the last block footer, which we also need to update its size, and we just make it equal to whatever the header is, right? The reason why we don't have functions for this, just like we have like, block is free or block set free, is because we don't really want, like, we want to do this only when we are sure that we can do it. So one way to sort of enforce that in a way is to make it difficult for us to actually do it, so that we think before doing it. Notice though that this guy, this guy that's at the end, he was before marked as a free block, and now it is still a free block, but it is a bigger free block. So what we need to do is we need to free it. Sorry, well, no, we need to eliminate it from the red black tree and then reinsert it. And that is going to happen over here. So update the block. First, get it out of the red black tree. Its size is about to change. So we're going to say red black tree, remove who? Well, the last block, right? Right? I think that's what it accepts in an argument. Let's see. Oh yeah, it needs also the red black tree we're talking about. So remove from this red black tree the last block. Now we update the size. Update the size. So update the size. And then we reinsert it into the red black tree, because now it's like new, right? So now we insert it again, and we're going to say, well, insert into my red black tree this last block. Perfect. Awesome. So now I think these comments are like a little bit extra. I'm gonna leave them there just to guide us a little. Get it. It refers to last block out of the red black tree. Perfect. Are we below 100 columns? Yeah, that's fine. Okay. Now, I want to hide this too. It's very annoying. Okay, so we get it out of the red black tree and then we insert it again. So now it has the updated size. What else do we need to do? Once that has happened, that we have expanded sort of the block by that much. Ooh, there's something that we haven't done correctly. And it's the fact that here, when we're searching the red black tree for a free block, it's sort of like, it finds the best fit block. So imagine that the program starts, right? The program begins. And so we're gonna have a huge block, maybe like a 52 in the case of this drawing, 52 byte long block or something like that. 52. So what the program is going to do on the first request is it's going to try and find a block that can satisfy that request. But there's only one, the 52 long one. So then what we do is, oh, if you found one, yes, we did find one. It was the 52 long block. Just give it to the user. And that's a huge problem, because it means that we're giving to the user the entirety of memory. Right? Like, sometimes if the only available block is too big for our request, it means that we need to partition that block. So it is a to-do. This is a to-do. To-do. If the found block is too big, partition it. How we're gonna do that? Not sure yet. It is, if anything, something we will decide later. And yeah. Currently, I'm not very sure. Fish ready now. Are you still in the stream? I don't know. Let's update the size and reinsert it into the red black tree. Um, yes. Okay, okay. You're the only one here, so that's good. Um, it is an unfortunate time to stream at because most of the world is asleep. Europe is asleep. Um, the East Coast is asleep. The West Coast is the only one that's mildly awake. Seems like the East Coast is not asleep. Um, judging by, you know, sometimes they're very awake. But yeah. Um, let's see. Okay, reinsert it into the red black tree. So now we're gonna insert it. Um, slow down, you crazy child. Mhm. Let me think. Yeah, not sure what to do now because let's see. If we expanded the heap by that much, then we sort of need to run the thing again so that the block it finds is the actual one. So I guess it's like we're gonna have something like return, and then we're just gonna return the same thing that we return over here. So this is gonna be a char pointer to the block pointer of whatever we're talking about, which is the last block. And then that to that we add the necessary amount by which we need to skip the header. Oh, hi Nick Vorsa. Well, welcome to the stream. Hope I hope you're good. Welcome. Because yeah, I mean it's a little late here. Around it's like 7 p.m. and the majority of the world is asleep. So glad you're here. You become a regular chatter. Um, uh just to allow you to catch up with what we've been doing, which is basically nothing. Right? It started only 1 hour ago, and that's very little considering how much I stopped to think about like random stuff that ends up being not that useful. Um, we have the malloc, we have the initial if statement where we um, sort of perform the lazy allocation of all our data structures if it's the first malloc call. And here in a normal malloc call, well, first we search the red black tree for a free block, and I detected today this to do. So currently what we were doing is at the beginning of the program, right? What you're going to have is this huge block that say it's 52 bytes for the sake of an example, right? Say the user asks for only 4 bytes, then we're gonna go here, find the best fit block, but there's only one block and that block is 52. So if there is such a block, we're currently just returning it to the user. We're just giving it to them. So it means that to the user, we just gave an entire 52 long block, which is kind of funny. Not only that, but we haven't removed it from the red black tree. So, okay, yeah, this is really bad. I think I just needed to do the to do we haven't previously. And we also need to say, well, remove from the red black tree whatever you gave me, because this thing is now taken. Yeah, perfect. I think that's sound. Okay, and so this to do really important. If the found block is too big, we need to find a way to partition it, and that also involves the decision of what does too big mean. Because if you have like a 24 byte block, and after partitioning it to accommodate for like a 4 byte section, you may be left with only like 8 bytes or 4 bytes. And then now we have to consider, well, is it really worth it to include an extra node in the red black tree, make the search slower just to keep track of an 8-byte block? So we need to decide, like, at what point do we partition? At what point do we say, yes, this is worth it, rather than just gifting it to the user? So here, let's see. Block pointer, think of it as a free block, add it to the red black tree. Yeah. So that's a different problem. Here we're tackling the problem of what happens when the last block is, or when there is no free block. Then we expand the heap, and this is what we were talking about yesterday. Well, if the last block is free, we're gonna find that last block. We're gonna say, okay, the amount of space I need is this much. And if that last block is free, I can reuse the space that that last block was occupying, and then simply subtract it from the space I need. And now I calculate the expansion size by taking the maximum between the expansion factor of our heap and the space I actually need. Because it is possible that, like, maybe we need a humongous amount of space, in which case it beats the expansion factor. And since it is so big, we can just expand the heap by that exact amount. There isn't really a concern for alignment, at least on my side. And the reason for that is we actually know there is. Sorry about that. Forget everything I said. Yeah, yeah. Forget about that. Forget about that. Because, well, actually, so say we start at 0. Da, 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 da. Yeah, so we don't need to align the expansion size. We need to align the total space that's needed, right? And by that I mean, okay, because only blocks require a byte alignment. And this expansion size, suppose that, like, this last free block, right, has something like, I don't know, like 5 bytes, right? Completely bogus example. And then we expand the heap by like 3, right? Then it's possible that at the end, this ends up just being a byte aligned, and we don't have to worry about adding more space or adding less space or whatever. I just need to figure out the fact that, like, as you can see, we didn't align the expansion size. The expansion size is 3. What we care is aligned is the entire block at the end, not the expansion size. So we don't add the align here. We should add it, not in needed space. Or, well, yes, in needed space, actually. Well, no, not in needed space. I think we're gonna do it here. So, well, actually, let me think. I'm going to make it this. Yeah, the block size is inherently 8 byte aligned, right? So, yeah. So in order to do this, we're going to consider the size of the new block. And this is the case where there's no free block, so we need to expand the heap. We're going to consider the block size to be already aligned. We grab this needed space, go to the block size. Oh, this is interesting. feel this is messing up everything. I'm trying to think of the following. So if we go back here, right, the structure of our block, the usual structure that we've been really familiar with. Let me see. Ah, that's okay. So whenever we have, oh wait, a message in chat. If block size is greater or equal to align size plus partition size, do partition. What do you mean by the partition size? Like the variable that you put in there. I think okay, if what you mean is if we have a big block and then we sort of partition it, I'm not sure if like that is like the is that what we actually want? Because wanna maybe you have like space in memory where once you create the partition, including the metadata and everything, you're left with a 4-byte block and then I don't know, like a 44-byte block, right? So if you got this big block of 48 and you needed 44 to give to the user, then you could partition the block of 48. And when you partition it, you're left with a 4-byte block. But this is, for all effects and purposes, useless for us, right? Because it's such a small amount that nobody's going to try to malloc 4 bytes only. And not only that, it's such a small piece, but it still occupies a node in the red-black tree, which means that now we make search slower if this behavior repeats. So there is a threshold at which if what you need is 44 and we have a 48 long block, then I'll just give you the user, I'll give you the whole 48. If what you need is 44 and what we have is 50, then I'm going to still give you the entire 50. But if what you need is 44 and what we have is like 78, then we may consider doing splitting. Right? We may consider being like, okay, 44, and now you are going to be 34, right? But like there is some threshold, some like something at which we say, yes, this big block, it's worth splitting. And that's what I was referring to, like sort of deciding when to split, right? Like when is it worth it? It could be something like, oh, by the time that the block that's left from the partition is, I don't know, at least 20% from the value of the original block or something like that. We'll see. I think we will end up deciding that. But for now, we were looking at and let me know if that's what you meant, because as you have already seen, it's very easy for me to misinterpret what you guys want me to understand. So yeah, that's all. Let me know. So here we have the problem with the alignment. Yeah, I think that's what we were talking about, where this whole block size needed to be like aligned, right? So let me think. Okay, the free block at the end, it's going to have a size that is 8-byte aligned, just because of the way we have coded everything. Which means that if we 8-byte align the expansion size, we would be perfectly successful. Right? There'd be nothing to worry about. Because 8-byte aligned plus something that's also 8-byte aligned is 8-byte aligned. And we're not using extra memory, because we would have needed that expansion size either way since it's already accounting from the size we're reusing. So rounding it up to a multiple of 8 would not use more amount of memory than if we were to round up the entire thing. So yeah, I think we can simply solve this problem by aligning the expansion size. Yeah, I feel like I was just going in circles there. Perfect. Okay, so once we have that, um, so if that block is free, the last block, we're gonna reuse its space. Then we calculate the amount by which we need to expand the heap. And once that's done, we need to update that last block. So currently, suppose that like the last block is a size 12, right? And the user is asking for 24 bytes. Then we're going to expand by, well, maybe not by 3. We're gonna expand by like the expansion factor or whatever, but let's do it like naively, right? We're gonna expand by 3 more to accommodate for those 24. And then we're gonna need one more little box to store the new size. The thing is, as it stands right now, this 12 byte block is, from the eyes of the red black tree, still a 12 byte block. So now we need to update this node's information and update its position in the red black tree because it's bigger now. So it's possible that it moved to another place in, like, in our binary search tree. So we remove it from the red black tree. We update its size on the header, and then we update the size on the footer, and then we reinsert it in the red black tree so that it occupies sort of like its new position. And once we're done with all of that, we give it to the user. Now, it is sort of something we need to have in mind, and is that we need to align. No, sorry, not align. Consider if we need to partition, which is the same to do as before, and also given that we will give it to the user, we may not need to reinsert if we don't partition. So yes, we need to update the size and everything, but in the end, we're going to give this to the user, which means that at the end, we're going to end up removing it from the red black tree. So why are we reinserting it, right? We would only need to reinsert that block if we happen to decide that we need to partition it. So then we give a part of the block to the user, and then the other part we need to reinsert into the red black tree. But if we give the entire last block to the user, then there's no reason for us to insert it again to then remove it from the red black tree. So it is something important to decide. Let's see, cause you choose. So 8F, you do size equals alignment size from the start. You will never think about that again. Yeah, I feel that's what we should be doing. My only problem is that we have that situation where the header, if we visit the struct, right? The header is 4 bytes, 4 bytes, 4 bytes, 4 bytes. So in total 16, which is 8 byte aligned, right? And now the problem is the footer, because the footer only has size. And size is 4 bytes, so it's not 8 byte aligned. So 8 byte aligned plus the user size, which we could 8 byte align, is also going to be 8 byte aligned. So this section is 8 byte aligned, is compliant. But then the footer ruins everything because it's only halfway through. And that's why I've been doing the align, not of the user data, but like of the entire block, because the footer messes up everything. At that point, one could consider, well, why don't we just make the footer be 8 bytes, right? And whatever you were going to donate to the user data in order to make this 8 byte aligned just goes to the footer. Um, it is a possibility. We could incur, nonetheless, in more memory usage that way, because it's possible that if the this guy is 4 byte aligned, and whatever the user ends up needing here is also 4 byte aligned, then these two complement each other, and then we save the 4 bytes that we would have given, which for a single block, I agree, is not that much. If this was a single block, I would immediately say, yeah, let's just make the footer bigger. But given that we could have, and that it's not only that we could have, we will be measured, and like all the metrics and our score and etc. are going to be based off of the memory usage. We need to be a little bit more conservative in, like, on like how we use the memory, unless you see some insight that I'm not seeing right now. Something similar to how, like, the reason why this align actually works, that before I was like, no, it doesn't work because, like, this guy is not gonna be like in whatever, and it ended up being just like, if you approach the problem from a different perspective, this align makes a lot of sense. um so yeah, that's I feel that's the reason why I've been doing the align, not on the user but on the entire block. mm, so yeah, we'll see. Let me know if there's something different that you think. Um, Currently, as it stands, this is. Let's see what these comments say. So think of it as a free block added to the RB tree. Yeah, we do that. Include the new free node in the red block tree. Update the ghost node. I think these were just comments to whenever we expand. So yeah. Include the new free node in the red block tree. So the now expanded node, we put it there. And then we update the ghost node. This is automatic, so goodbye. Insert the ghost node at practical address 0. We've already done that. And then proceed as usual. This is already there, so no. This returns 0 as extra. So this is our code. And then we need to solve all of the to-dos. Do you give to user the footer too? Or is it included inside its data? Because I remember it's not. Yeah, for the user's data, the user is not supposed to like touch the footer, right? If they like write information to the footer, then that would be memory corruption, right? Like they'd be using, that'd be like an out of bounds access in that case. So yeah, footer is not part of user data. So whatever size they're specifying is the size of this guy. So yeah. Let's see. So, let me think. Also, something I wanted to check is, how do you see the red comments? Like, hello, this is a red comment. Like, does it still have that weird effect where it would like shine super weird? Let me know, because I increased the quality of the stream to now be 1080p. So hopefully that fixes it. I'm not sure, because now the kbps are stable compared to yesterday's stream where it was a hell. Yeah, I digress. Okay, now that we have this, we need to solve a bunch of. Okay. Oh, but footer is not needed after you give data to the user. Only when it free its data that you insert the footer. Not really. We still need the footer to be there. And the reason is because if we have, right, taking these two blocks as example, let me see, let me see. The reason we have the footer here is to allow for sort of coalescing blocks. That is, if this block gets, say this block is allocated, so the user has it, and this block is allocated and the user has it, then whenever both of them get freed, we need to merge them. And the way that happens is once this block, so if it happens in this order, so they're allocated and allocated, suppose, the user frees the one on the left first. Then they're gonna pass us a pointer to user data. And then from here, we know how to access the size. So then we can skip ahead to the next block after that and check whether or not it's free. If it is free, we merge them together. So in the scenario where this one is the first one to get freed, we don't need the footer, I agree. But if the one that gets freed is the guy on the right, that is when we need the footer. Because he's going to say, okay, to my right, do I need to merge with someone? Ta-da-da, checks that. And now it says to my left, right? Do I need to merge with someone? Because it could be the case. You have them both allocated. This guy gets freed, looks to its right, and it says, oh, this guy is allocated. He's not free. So then he doesn't merge. But now this guy gets deallocated. And then he's going to say, okay, if he were to only look to his right, then we would be left with fake fragmentation. And thus, he also needs to look to its left. And that's why we have the footer here. So this guy would need to read the footer. Oh, but I see what you're saying. I see what you're saying. But it would still not apply. So here, he would need to look at the footer and then travel to the header to see if it's free. But if the situation is given where both of them are allocated and the one on the right is the first one to be freed, he's going to execute and suppose that like the footer is now garbage data in the sense that the user writes into it. Now, if this guy gets freed, he's going to say, I look to my right and does whatever, and now I look to my left. And so he tries to read the footer, and then it's random user data, and so he travels to some random location in memory, and then we have a security vulnerability. And not only that, we have a correctness issue. So I think we need the footer to be there, like forcefully, because this guy cannot distinguish which scenario it is in until it knows whether or not this block is free. But for that, he needs the footer. So I think we're forced to store the footer at every point in time. So yeah, although that it was a good observation, I think we definitely need it. Unless maybe there's like a secret way, like maybe we XOR two things together and like all of a sudden now we don't need that size. That would be nice, but yeah. So, let's see. Currently, the only to-dos we have is find a way to detect whether or not this is our first allocation. We have another to-do, which is merge the two break calls. And I think we can do that right now. I think this is the easiest to do to tackle, so let's do that. So here, UN32T, and then this is just gonna be called the padding that we need to add. And that's just gonna be this variable. Stores that. And then we put it here. And now we also need to know what is the ghost node size. And that is going to be this. There you go. Okay, perfect. Uh, is it actually? Wait, who is it? Oh, it's this. There you go. Perfect. So with that in mind, we simply say, okay, expand the heap by the amount of padding we need plus the size of the ghost node size. And now we also need to know where the ghost node is located. And for that, we need to grab the low end of the heap and add to it the amount of padding so that we end up wherever the ghost node is starting. And this guy, I think we can just convert to. Well, actually, it would just be the padding, right? Yeah. So if the padding is 1, then the ghost node starts at address 1 with respect to the start of the heap. Okay, let's see. Uh, when you free. Oh yeah. Okay, get it. But I didn't know why they did that. Who's they? Who? I'm not sure what you mean by they. Like, do you mean like us? Cause, yeah, because we created this design. Like, we like the first day, the first stream, it's in the YouTube channel. We were like, all right, let's decide on what the size is. Um, it is nonetheless in like the most basic memory allocator. It is something that's present. But let's see. So users still can corrupt the footer, even the header too, with no defense from you still now, I guess. Um, yes, yes, yes. That is indeed the case. And in fact, like I think um it's not only I think, like I'm pretty sure that you can also do this with malloc. Like you could just perfectly corrupt the footer and the header and then and then things would go, to hell. We could implement something like a heap checker or something that allows us to know when the user modified something. Um, but it is the reason, I suppose, why like memory problems occur in the first place or like security vulnerabilities because you just have a pointer and we can have like protected pages and stuff in the operating system, but we cannot have like a protected, like region of memory um, as it stands right now. So yeah, we would have to see unless there is a way where you think we could just get protection for free, but just because of the way our memory model is working right now, I'm not sure if that would be possible. Uh, we would need to ourselves implement like a heap checker to check that nothing has gone bad. Um, I imagine the way we could do that is we could just have a completely different space in memory that the user doesn't know about, that for every single node stores like a hash of the node or something like that to check that it hasn't been modified or whatever. But yeah, see, checksum pushed in some place, but that's another problem for later. Yeah, yeah, yeah. I think we agree on that. Yeah, we agree on that. Um, yeah. So it would be like in the future, right, where we're like, okay, we have an actual memory allocator. Maybe if we want, we can implement sort of the security. Although, yeah, that'll be a problem for the future. So let's just define on that. I think these two variables are pretty self-explanatory. So I'm just going to remove them there. And yeah, I think set up those now over here. We have done this to do. Perfect. Now, find a way to detect whether or not this is our first allocation. We could. Okay, I'm going to burn me at the stake if this is a genuinely bad idea. But we currently have a static variable for the red black tree. We could simply just say is first and then just use it because it just remains as global state for every malloc call. So then we can just take a look at it. The alternative would be to in mem init expand the heap by 1 byte and then store the value there. But that would imply a potential syscall, which would be like the expansion of the heap for the first time. So I think we can just do this, right? Bool is first, and then that's all, right? False is its original value. Um, and then just like if is first time, then just do this, right? And make sure to set it back to false. So I feel that's fine. Um, let's use it as singleton. The check the check is cheap. When you mean what do you mean when you say singleton? Do you mean like the variable like this, right? Like a single variable that's called this first and that's it? Or do you mean something else? Let's see if I know when to detect or not, and I think this would be fine. I'm going to eliminate the to do. If we want to modify the way we do it, then we surely can. But I think we just solved it, so that's that's great. So lazy initial allocation, that command goes here. Perfect. Okay, so now we're gonna search for the red black tree, gonna look for a free block. We find arbitrary itself, no need to extra bool. Ooh, what do you mean by arbitrary? Oh, do you mean like doing something like, well, so do you mean storing it inside the arbitrary struct? Do you mean something like, I don't know, if the arbitrary block is simply not set, then uh this like then this is our first time? Or what do you mean? I think that could be an actually like an actual good one. So arbitrary block is just like a null heap pointer. And then if the arbitrary block is a null heap pointer, then we know that we haven't initialized anything. And then we saved the extra bool. Is that what you mean? Let me know. Because it definitely saves us memory. So like it saves us like 1 byte, but yeah. Yes, something like that. Okay, perfect. Yeah, so that makes sense. Yeah, pretty good idea. Again, perfect. Yay. So if we happen, I think we're done with our lazy allocation, initial allocation. So now let's work on like the actual malloc. So we search the red black tree for a free block. Then if we find a free block, we do this. Now this is the next to do. If we find a block that is too big, partition it. And now we need to define what too big means. This is this is something that needs a lot of brainstorming, I suppose, because of exactly like what I was saying before, now where you have like a huge block. At what point do you determine, yes, this is worth splitting, right? So 44, 34, and like 77 or like 78. Then it would be worth splitting a 78 wide block to accommodate for a 44 wide request. It wouldn't be if the request was something like maybe 70, right? because like with the headers and all of that, you'd be left with like 2 bytes, or just for simplicity, say you're left with 8 bytes. But like nobody's going to malloc 8 bytes. Or like maybe they would, sure. But it would be a little bit difficult for somebody to ask for exactly 8 bytes or something less than that. Um and not only that, but this guy is also occupying space in a red black tree, which makes the search slower. So we might as well, instead of providing 70 to the user, just give them the whole block. So now let's determine at what point do we say, yes, this is worth splitting. So let me know if you have any ideas on that. Currently, what I'm thinking is something like do it when sort of like either so I'm gonna move this either, and then the first situation would be like the remaining guy, which is the guy you partition. The remaining guy is the one that's still there. The remaining guy is like you know some like 48 bytes or something like that, and the remaining guy is like I don't know 40% of whatever this huge value is. Let's see. Neighbors has free space for at least 2 small requests with metadata, like 64 bytes can fit 2 blocks. Yeah, something like that. Okay, yeah, I had put 48. So yeah, I feel that'd be a good measure. Um, I guess things depend on the workload, and like we cannot really guess what the workload would be. So yeah, sure. I mean, uh, accommodating for small requests. Strings are one of those things that require like little space in the heap and so on. So sure, let's do that. So the metric that we can decide on is including metadata and everything. So metadata is 20 bytes long, including header and footer. And so with 20 bytes long, a small sized request, let's estimate it at 32 bytes or something like that. Or well, no, 24 bytes, right? So 24 plus 20, the metadata, that would be 84. So a single block, including its metadata, a small request of 24 bytes, yeah, would be 44. And then 44 times 2, that would be 88. And so, yeah, maybe something greater than 80. Does that sound right? Because I feel like just gifting, because if it doesn't reach the threshold, then it means that we'd be gifting like 79 bytes, which still sounds like a lot. Okay, so I'm saying 88, you're saying 64. I think we can, could we just, like, small request is under 8 bytes. Yeah, but like, okay, like maybe I don't have as much, because my thing is like, from my perspective, using the heap for 8 bytes sounds like a very silly idea. Um, Mainly because like at that point use the stack, right? Like and if you need it to be preserved throughout the duration of the program, just like I don't know, have a global variable. I don't know. But sure, okay, yeah. Let's take that stance. Um okay, meet me in the middle, meet me in the middle. Small request, let it be under 12. Meet me in the middle, so that'd be 22 and then 22 times 2. 44. Yeah, so 64 bytes. Yeah. Either way, so if metric, if the remaining sort of block after partition is 64 bytes or more, then splitting is worth it. So of course, I'm going to shorten this comment before, but sorry, after, but I think it's just good to have it as a guide. Either way, I think we can just change the policy whenever we want if we end up detecting like, oh, the number wasn't actually right or whatever. So let's see. So if, and now we need to calculate how we would do this. The best fit block, we already know sort of how big it is, right? And we can just, okay, block space, right? The space occupied. So block occupied space, because like block size is different from the space the block is occupying, at least in our program. Because block size refers to the amount of user data that it can collect, and then the space it occupies is like, anyways. Our naming conventions are not the best. We have to live with the burden of our decisions. It's okay. So the space it occupies, is the size of the header, the size of the block header, plus the actual size of the block. So best fit block. So the size for its user data, and then the size for the footer. So I'm seeing this, we repeat this pattern a lot. Maybe we can consider, I know I'm adding too many macros. I am so sorry. I'll just add it here as a to do. Like, consider adding something to simplify this expression. Like, although I feel the expression allows for clarity, so maybe we don't want to do that. Yeah, never mind. I don't know why I'm wanting to like create a macro or a function somewhere else. It's like the curse of like trying to abstract things away and whatnot. So yeah. Okay. The block occupies this much space, and we want to know after I give you, so if after we accommodate for whatever you need, which would be or whatever the user needs, like space needed by the user block would be size of the header plus the size of this guy plus the size of the block footer. And not only that, but we need to align them. So this would be aligned. And then this would also be aligned over here. Align. Perfect. So if the occupied space, right, minus the space that the user is going to, or like the space that we're going to need for that new block is greater or equal to 64, then we consider partition. So here, consider partition. And here we actually partition. Wait, there's an error that the compiler is pointing out. Oh yeah, I forgot the semicolon. Perfect. Okay, so now if the space that's occupied minus the space that's needed is greater or equal to 64, then we can just partition. So however we're going to do that, I think we have a function called partition block. Yeah. So partition block and then I need to give you which block I want to partition, and that's going to be the best fit block. And you're going to partition it into how much do you need, right? Oh wait, I think the smallest block size can be 32 bytes, so that 2 blocks can fit in 64 bytes for cache wise. Okay, I feel like these numbers are like a little arbitrary, so I don't think you're overthinking. Because the reason why we choose a given number is like a little bit arbitrary. So if you can add a little bit of argument to it to support one or the other, it like becomes the decisive factor. So definitely, sure, we can use 64. Makes sense to me. Yeah. So we can have this guy, right? So block agent space, and then space needed, and we partition the block. So our interface for partitioning a block is I pass you the block, and second block size, it just makes no sense. So we then accept sort of the size of the section we need. So partition block, and then size left. Like, this is conditional on the fact that I'm thinking of the block as like quite literally being in our memory. And so if we have a huge block, I would want to specify the size of the block on the left. That is, I would want to say, give me these many bytes and put them on the left. I'm not sure if that name for a parameter is good. Naming things is like one of the hardest things ever. Partition block. So we partition that block, and then we specify the size. What name do we give to this guy? I'm gonna leave it as size left. I think it's not like I'll add it to do, fix the size left name question mark. Like, do we want to fix it? Is it a good name? I don't know. But what I do know is that the space needed is going to specify whatever size we're gonna have on the left. So yeah. Once we partition the block to be that, we need to remove it from the red black tree way before. Perfect. So if we find, let me eliminate the to-do. The metric is pretty clear from the if. So yeah. So now, if we find a best fit block, we remove it from the tree, which means this thing is going to be allocated now. We're going to have how much space does it occupy, right? How much space it's available on this huge block versus the space that's actually needed. And then we're going to consider, well, if the block space, right, minus the space needed is greater or equal to 64, then we partition the block, right? So, and once we partition the block, we have the left side be the thing that we're going to return, and that is still the best fit block pointer. And here I would need this function to return to me the second, sort of the block that's on the right, right? So that guy would be like remaining block would be whatever this. So what I'm thinking right now is we have this huge 78 wide block. Say we specify 44, then it is going to it's sort of going to partition the block. It's going to leave the 44 on the left because right? That's the way our memory is structured. This has a block right here. And then it's going to leave this guy, which is going to be free, to the right, right? So whatever's free is going to always end up to the right, which is good for the case where we, for example, have, at the beginning of everything, where our memory is completely empty, we're going to need to partition. So we definitely want the right part to be empty, um, to be like the empty one, the remaining space. And so this partition block is going to return the starting address of the remaining block. I think that's fine. Oh, chat message. Sorry. Let me. Oh, seems like my earbuds are about to die. So let me charge one of them while I use the other one. Not the best strategy, but okay. Let's see. So 64 bytes. So cache wise. Oh yeah, we read that. Requested size. It will end in the left. No, right. You need to insert the removed part too. Okay, so requested size will end in the left. No, right. I think the requested size is gonna end up on the left. If by requested size you mean the guy that's gonna be on the left. And that was the stupidest thing I ever said. I think the requested size is gonna end in the left. If by requested size you mean the guy that's gonna end in the left. But yeah, you understood what I was trying to say. Yeah. Uh, and then you need to insert the remove part too. You mean like the remaining block? If so, I agree. Like, because now the remaining block is free, and so we need to insert him back into a red black tree. And that's why I wanted the partition block to return a pointer to the remaining block. So then we insert into this arbitrary whatever the remaining block is. Yeah, that sounds about right. Right? And so, yeah, I feel this is all we need. And this consider partition should be here. Okay, I think this is the logic we want to follow. Let me go through it again. We search the red black tree for a free block. Suppose we find one. First, we remove it from the red black tree because it's no longer going to be free. We consider if it is too big. And that means once we use the space that we actually need, are there 64 bytes remaining? If so, then we consider this worthy of partitioning. So we partition it, and then we insert the part that's remaining. This assumes then that partition block is going to have in the doxygen, right? We need to specify them like it assumes or like this function updates both sort of the metadata of the blocks after partition, right? Because we need to make sure that like once we partition, this guy changes from 78 to 44 in the header, and same for the footer, and that this guy now changes from 78 to 34, and same for the footer. And we're just saying that like the partition block function will be in charge of that. And so you don't need to worry about inserting some bogus value because partition block will make sure that this is a valid block. So yeah, so we can insert it back in. And once that's happened, we can just return, the original pointer we had, and nothing's gonna be bad. I assume, question mark? Yeah, I think this is the logic, yay. Okay, so now. If there is no free block, we can expand the heap. Oh, this is the comment that introduces us to this section. Okay. Now to do test, this is actually correct pointer arithmetic. We are going to test that. So So I'll just remove the to do so that it doesn't confuse us with other things we need to do. And this is the last to do. No, there's two. Okay, yeah, we're plagued with to dos. Given that we will give it to the user, we may not need to reinsert if we don't partition. Oh, okay. So here, so now when we expanded the heap, we sort of now need to suffice the user's request. And for that, what we can do is we can simply apply the same logic as before. So this thing here, we consider partition, right? Consider partition, where the only thing we're going to do is, I mean, partition in a block is cheap. Since it's an O of 1 operation, we just need to update metadata. So it's fine. If, let's see, so how much space does this thing occupy? I think we can just use the values we calculated before, right? Where we have the expansion size, and we also know how much the block was using before. So this last block, actually, no, what am I saying? Just consider partition of that last block, and that is, right, the uint 32t. So we use basically the same code. I copy this, and then we go back here, and then we say, okay, so this block's occupied space is going to be equal to whatever the, you know, the size of this block's header is, or like the size of the header is, plus the size that this block says it has. Because this is after we expanded, after we did everything, and then the size of the footer. And then the space we're going to need is going to be the space for the user. And finally, we say, well, if the space occupied minus the space needed is greater or equal to 64, then we're going to do the exact same thing we do up here. We partition the block, reinsert the remaining part into the red-black tree, and then we consider it we need to partition. Right? So once that's done, we simply return whatever we want. And they are mimics of each other. Let's see. I think you need a function that finds a partition a block because you will call it twice in malloc. I think you need a function that finds and partitions a block because you will call it twice in malloc. So, oh, do you mean like performing the find and the partitioning, like just call a function that is like find ideal block or something like that, and that function is in charge of finding a block, and if it is too large, partitioning it? Because if so, like it is possible that it's just because that function would be just this, would be the entirety of this case. So I'm not sure if we would get benefit from abstracting it away because it's only used once in the code, at least this one. Because for this second case, we are not finding anything in the red-black tree. We sort of already know that the block we want is at the end, since there was no space. And so now we save the lookup in the red-black tree, but the cost for that is duplicating the code for the partition part. Yeah. So let me know what you think. Let me know if maybe there's something we could improve. I feel like the fact that this code is duplicated tells us that maybe there could be a way to abstract it somehow. We could consider having a function that's called partition if worthy. I'm not sure if we want to create a function to like a situation that occurs only twice. Let's see. Yes, after you increase heap, call it for new balanced tree. Call it for new balanced tree. Call it for new balanced tree. What do you mean? Because now here when we insert the remaining block, the tree balances itself. So why would we need to abstract this part away? Because if it is find and then partition, then it would only be used once because this is the only place where we try to find something. Here we don't try to find anything because we already know where it is. So it means that the function would have to be this whole thing, this thing right here. And do we want to abstract that to a function? It seems like it's simple enough, but it's also complicated enough. Mm, hmm. I don't know. I don't know. You have me doubting because it's only like what, 5 lines, and we use it only in 2 places. But at the same time, I feel it would make the code easier. Hmm. What did you do after increasing the heap? Okay, so yeah, because I feel I was not understanding what you were saying. So we expand the heap, right? Then we remove we expand it here with this. We just remove the last block from the red black tree because its size is about to change. So that changes the structure of the red black tree. So we remove it. We update the size. And before reinserting, since we already know that the last block is the one we want, we consider whether we want to partition it. If we end up deciding that we do want to partition it, only then will we reinsert the part we want to use. Then otherwise we just return sort of the block itself. So is what you're saying related to this? After you increase the heap, call it for a new balanced tree. Yeah. I feel the exact job like before. Yes and no. Like this part is indeed the exact same thing as before, but only that part, right? The one I had pointed out before. Well, sorry, like this part. And like we could abstract that one away. The problem is, well, first of all, this remove cannot go there in that function because it is important for the sake of the tree. Yeah, we need to remove this before we modify the internal tree structure because this relies on the tree being a valid tree. Yes, you partition the new heap. Yes. Like this is the same job. Are you referring to the fact that this piece of code is repeated? If so, we agree. Like the part where we consider whether we want to partition, yes, because it's also here. The only doubt I'm posing is the fact that like, do we really want to abstract this away? Because like 5 lines, 6 lines actually, or 7, I don't know. 1, 2, 3, 4, 5, 6, yeah, 6 lines. And like it's not as bad, but okay, let's do this. Partition is worthy. or like um or like partition partition if worthy is it like evokes the right idea, but I'm not sure if there's a better name. Okay, let's think of a better name while I write the parameters. So you would pass in a block, and you would pass in by how much do you want to partition the size. Um, you increase the heap and let the function find the partition. Yes, so we could do something like increase the heap. Where is it? There you go. Increase the heap, then update the size, and remove and then reinsert it into the tree. Reinsert it into the tree, right? Last block. Once we modify its metadata so that it rebalances. So reinsert or rebalancing. And then we could call the function that finds a partition and sorry, that finds a block and then partitions it. Sure, but that would be unnecessary. And I mean that in the sense of speed, right? Because performing a red black tree fine, if we have a lot of blocks in a completely unnecessary scenario, is like, we're taking a toll on the speed. Currently, we know for a fact that that block that's going to be returned is last block because it's the only block that can ever be returned. Since the reason why we're expanding the heap is because all of the other blocks didn't work. So like we already know the result. Why would we try and find again, sort of try to run the finding algorithm again and going through an entire traversal of the tree? Not only sort of incrementing the amount of time we spend here, but also damaging potentially the cache because we'd be running like everywhere. So yeah, like that's the reason why I don't want to do the function including this part. And that's why I don't want to put, because I could also put this block before it. But yeah, I do think we can meet in the middle. I feel we can reconcile what, because before I was like, nah, this thing doesn't need to be a function. I feel like I see the value of what you're saying, so I think we can just create. That's why I was naming it for like partition if worthy. So it's like, partition if worthy, where we pass in a block, right? We pass in the size that we need to partition it by. And then over here, we include the code that allows us to check whether or not we want to partition something. Partition if worthy. And now all of that sort of, goes away, and we simply call partition if it's worthy of being partitioned. Who do you want to partition? I want to see, is best fit block worthy of partitioning? If so, just have in mind that what I need is, how much space do I need? I need this much. So space needed is over here. Where is it? I lost it. I lost it. Where is it? Over here. So then I say, okay, the space that I need is this much. Partition best fit if worth it to accommodate for a space needed size block. And then return, right? I feel we would be hiding a lot from the user because not only are we hiding, so the partition fact we're not hiding, we are hiding the fact that we are reinserting into the tree. So if we want to be like explicit, Andrew, hello, welcome to the chat. Andrew Krevsky, welcome. Hello. What time? It's early for you. It's probably like 6 a.m. That is, thank you very much for joining the stream. I'm glad you were able to catch it. Yeah, currently we are working as always in the memory allocator. It's late? Wait. It's 8 p.m. here. So where you are is 10 hours difference. So it should be 18 and that should be 6 a.m., right? Which is like for me to go to bed, bro. I thought you just had woken up and that's why you joined the stream. What do you mean? So you haven't gone to bed? What are you doing in the stream? Go to sleep, bro. I want you guys to be healthy, bro. Thank you for the dedication, though. But well, okay, so like, dang, you haven't gone to bed. Okay, that's crazy. 4 a.m. here between the two. 4 a.m. What? Wait, Nick Borza. Okay, dude, guys, you have like complete red eye. Like, wow. Okay. Do you guys just not sleep? Like, there's people like that. There's people that like they like fully function and they can think very well, and they just sleep like 3 hours or 4 hours. But thank you very much for joining. Thank you. Because it's I appreciate you guys and like it's fun when like you guys join the stream because then there's people to talk to and to discuss things with. Um. Oh, okay. So you woke up late today, which means that you can stay longer, and so that's why you haven't been to bed. Okay. I hope that's the explanation. Yeah, pretty good. You're on vacation. Yo, that's awesome. Um, but yeah, I mean, I'm glad you guys are not just you know killing yourselves over the over the like finally getting in. Yeah, hopefully everything's fine. But yeah, so I don't know. Basically, we're working on the memory allocator. I feel it's good if I just give you a walkthrough through the malloc logic, just to check ourselves, because this is very important. As you can see, we got rid of a bunch of the to-dos, uh, basically all of them. And currently, so malloc is finished, allegedly, right? Because like we're going to find thousands of bugs in this thing that we're gonna have to fix. But for now, the core logic is supposedly there. So on our first call to malloc, we want to perform that lazy initial allocation. And by that I mean like if the user never uses the heap, there's no reason for us to store the ghost node or the padding and all of that. So we just wait for the first allocation to happen. And we detect that by knowing whether or not we have allocated a block for the red black tree. If we haven't, then it means this is the first time. So we compute the amount of padding we need, we compute the size of the ghost node, and then we simply expand the heap by that much. Then we tell the red black tree, this is the address of your ghost node, which is going to start from the beginning of the heap, an offset of padding. So it's a heap pointer. And then we set the sort of left child of the ghost node to be null. That is, there's no root yet. Because remember, this is the ghost node. Now, here comes the logic of a usual malloc call. So forget about that. And here, first thing we do, we search the red black tree for a free block, right? We find in this red black tree something that is able to accommodate the size that the user just asked for. Now, if the best fit block, we actually find one, then we remove it from the red black tree because it's no longer going to be free. We calculate, okay, how much space do we need to store the user's information? Because it's very important. This is important in the sense that you can imagine the moment where we first start the program. So we have like all of this memory that's over here, right? Say there's 52 bytes at the beginning of the program, and the heap is like super large. 52 bytes is not that much, but like for the sake of the example, what we would do here if we were to not have these lines, it would be we find a best fit block, and the only block is the 52 byte long one. So we just find that block and then we give it to the user. So we have given to the user all the memory we have available, and that is suboptimal. So if the block we get, right, if the only block that fits us best is a block that's too big, we want to partition it. We want to sort of cut it and divide it in two and give one of those parts to the user. So we calculate how much space we're going to need, which is this, right? Space needed is the block header, the size, and the block footer, and then align them. And we partition if it's worthy, or like, I felt like rather than worthy, because the block is worthy of being partitioned, but like, I feel it's better if we just say worth it, if it's worth it. If it's worth it, we want to partition the best block, having in mind that we need a piece to accommodate for the space needed. And then whether or not we do that is determined by the function. Finally, we return the best fit block. In the function, the only thing we do is space needed. There you go. Sorry, the only thing we do is this. We see how much space is going to be occupied by sort of the, or like is currently in memory. So this huge block, how much space does it occupy, including its header, its size, its footer. And if we have that that space minus the space we need, that is, once we partition, if what remains is at least 64 bytes, then we say, okay, that's worthy of keeping. So then we keep it, right? We partition the block and then we insert that into the tree. Otherwise, we don't do anything. So the reason why we're considering this is because sometimes it may not be worth it to partition, right? If you have like a 52 long block and then the user asks for like 44 bytes, sure, you could partition and then like be left with like a 8 byte block. But then like 8 bytes is very little, right? Few people ask for 8 bytes. And it is such a little piece that it's probably never gonna get used. And also it is another node in our red black tree. So it introduces search overhead if we just keep it being independent. So we might as well just give it to the user so that we don't have to worry about him. And the threshold we determine is after 64 bytes, it's worthy of keeping. We can completely sort of change that, but for now, we just have it that way. And then we return, right? If there is no free block, then it means that we need to expand the heap. And this is the thing we had yesterday. We go to the last block. We take a look at the block size. We see how much space do we need, and that's going to be the block size. If the last block is free, then it means that we can reuse some of its space. And we are going to subtract from the space we need the amount of space we can reuse. Finally, we calculate the amount by which we have to expand the heap, and we actually expand it. Now, we don't really need to find a match for the user's request because we already know that that match is at the end because that's the block we just expanded. So we simply remove the last block from the tree, update its size, because notice that all we were doing here was just expanding the heap. We never really moved sort of any of its metadata or like things of that sort, which actually introduces a bug. There you go. Okay. Notice that nowhere do we set the footer of this new block that we created. The header stays the same in the same place. That's why we update the size. But nowhere do we set the footer, right? Yeah, we're not doing that. Okay. That means that we need to do that. And so we grab the block pointer pointed to by the last block. Actually, that wouldn't be a block pointer. It would be like a block footer, right? Pointer. And that's going to be the block pointer for the last block. So this is the pointer to the header. And to that, we need to add the size of the header. So after we do that, we would be at the beginning of the user section. And then we need to skip the user section. So size of the user section, which should be like, where is it? BK size of last BK. Yeah, there we go. And then once we're there, we're gonna be at the first byte of the block footer. And what we want to do with it is dereference it. Okay, I'm gonna hide this Excalibur because it's very annoying. Dereference it, and then, or actually just access its arrow operator to compute the, let me close this. Let's see if autocomplete works. Yeah, size, and then we set the size to the new thing. Yeah, so here what we were doing is incorrect. We just, right, this is just garbage. And thus we have it. I think we just set the size to be whatever the block size is. Perfect. Okay, yeah, that makes more sense now. Can't believe we missed that. Okay. Okay. We reinsert for rebalancing. So once we have expanded that last block to make it bigger, then we say, oh, this is a new sort of view. Oh wait, this was here while I was making an example. So yeah, so once we have that block at the end, we're going to consider now we want to partition it. So all of this is just going to be a call to partition if worth it. The last block, please partition it to accommodate for how much? The block size? Yeah, the block size, which is what the user is going to need. So yeah, and this should be enclosed by an align. Perfect. And so now once we partition that and everything, then we return. So we were debating on the nature of this function, partition if worth it, because we're hiding from the user the fact that the red black tree is being inserted into. And we're like hiding that fact from ourselves. So what we can do is partition is if worth it is just gonna do the same thing that partition does. Is simply going to return the block that remains, and we can see. But now the function is like super slim, so it wasn't really that worth it. I don't know. So h pointer remaining block is equal to this. Then if there's a remaining block, then we want to insert it. I guess it's easier to read though, right? It's easier to read, right? I need this much space, partition if worth it, this best fit block, and if there's actually a remaining block, then just insert it again, right? Now it's easier to read. There's no fact that's being hidden from me. I know exactly what this does. It partitions if it's worth it, and it only does that. It partitions, and that's its only responsibility. So I feel it's better if we do it this way. I guess we would update it here too, where we simply say, well, the remaining block, it's equal to this. And then we say, ooh, yeah, 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 yeah. Okay, if the remaining block is actually there, that is, if we ended up partitioning something, then we need to insert into the arbitrary whatever it is that's remaining, because it's still free. Perfect. And so now we've been able to, to sort of improve the readability, I would say. Otherwise, we return null heap pointer. Perfect. I think this is exactly what we want. This is no longer needed because I feel the name partition if worth it is pretty self-explanatory. Yeah. I feel like here I'll just say sort of like give block, give to the user the block, then yeah, there you go. So I think this is the end of our malloc. Well, not the end, right? Like the illusion of an end, because right now, you know, the amount of mistakes we're gonna discover is a little bit big. Yeah. So. Let me check that this is correct. So once we have everything, once we partition and all of that, we return this. Yes, we return this. Okay, I think the logic is there. The last thing we need is to implement the partition block function. Right, so this updates the metadata of the blocks after partition. That's a remark we make. And there's also a sort of remark or like a warning, although or like a requires clause, or like a precondition. I think is pre an unofficial doxygen tag. Let me just, is pre an a doxygen tag. I know, guys, I know. Nobody cares about the doxygen, but precondition section in the generated documentation. Yeah. Okay, perfect. Preconditions. So a precondition is like a requirement that block can actually accommodate for accommodate partitioning into blocks where the left is. No, I mean the block can actually accommodate for this partition, for the requested partition. I feel that's better. Yeah. So I feel let's update this to size needed. Okay. So we want to partition a block to the size that's needed. And the way we're gonna do that is we're gonna grab. Okay, how do we do this? We already have a block, so what we need to do is we need to update its metadata and all that stuff, right? So size UN32 for the size left block would be align, please, size of a header plus the size that you're going to need plus. Okay, it's important to note what size needed is. I think we are going to specify that size needed is going to refer to user size, right? So size needed is size needed in user size, i.e., do not include metadata. Okay, that simplifies our lives by a lot when we use this function. So then block footer, perfect, size left, and then the size of the right guy is just going to be total space on the left is going to be that, and the total space on the right, it's going to be the same thing. We need to align to size of block header. So actually, it's just the fact that this one's tricky. So our block is something that's 8-byte aligned. Okay, wait. Our partition block is allowed to call insert and remove. So you mean for the tree? I want it to be like a rule that no. Why? Because we don't want to hide things from the user. And by that I mean, if in the code I see a function called partition if worth it, then I know that it's going to partition the block. But if this guy, apart from partitioning, also inserts in the tree and also removes from the tree, I cannot tell that at all. So, right, from the code, I wouldn't be able to tell, oh, this is actually also modifying the tree. So it would be an argument of separation of concerns where, like this guy should be doing one thing and that thing would be whatever it's describing in its name. Because if we start modifying the tree also, and then we remove and then we put, it like gets completely abstracted away, and we lose track of what's actually going on inside the function. So that's why I prefer to have partition if worth it like that, and partition block will just be in charge of partitioning the block, which is a non-trivial task, and so we just have it here, and yeah. So there is something that scares me deeply within my heart. And that is the fact, okay, if you have an 8-byte aligned address and you subtract 8 from it, it is still an 8-byte aligned address, which means that whatever remains from the block size, so I'm going to create a variable here called total space, and total space is just the block size of my block, but to that I add the footer, so the block header, and then align all of that. The block header plus the block size plus the block footer, block footer, block footer. Okay, plus the block footer. And then space on the right is gonna be the total space minus whatever the left already occupied. Total space left. So what I was worried about is the fact that what if, what if you have like a huge block, but after you create the first half, the second half, for it to be 8-byte aligned, would need like less bytes or more bytes. So it cannot fit exactly into the space it's been given. And thus we have like 2 bytes floating around or 3 bytes floating around. But then just realize that like if the total space is 8-byte aligned, that is a multiple of 8, and you subtract from it a multiple of 8, which would be the space on the left, then you're left with a multiple of 8. So this would still be a multiple of 8, and we would be fine. I want to include an assertion for the fact that the total space on the left, that it is able to accommodate for that, and that here the space that's left on the right can at least accommodate not only the size of a header and not only the size of a footer, but at least like what, 1 byte, no, 0 bytes, right? This is an assert, right? So if you call partition block, you need to at least have the ability to accommodate for the requested partition. And so I just need you to tell me, yes, I'm able to have in here this, this new block. And so what we can do now that we know this information is simply update everything. So on the left, we are just going to do this. So we consider as a block pointer the total space left. No. What am I talking about? The block. And what we do is we're going to update its size to the new size it's going to have, which is going to be the size needed. Right? Now, for the block pointer, well, I'm starting to think of something. Let me add it as a to-do at the top so that we can revisit it, and it's important. Whenever adding bytes to a block for the sake of alignment, comma, we should expand user section rather than footer because it could improve the chance of sort of finding blocks for future requests. What I mean by this comment is the way things work right now, we have our block, right? And if we need to add to it a little bit more data just for the sake of alignment, then we expand the footer. What I'm saying in that comment is we should instead expand the user data. I know it's more difficult, which is why I didn't want to do it. But if we expand user data, it means that we can change the size to be bigger. And so a future request will now find in that red-black tree a bigger node they could get inserted into. So expanding user data, even though the offset in the sense of like bytes is small, it could save us in some scenarios. So we should consider doing that. And I'll just add it as a to-do. Once again, it's not a definitive decision because it also implies a little bit of complexity where like size needs to be like a little bit bigger. And not only do we have to align, but we also have to make user data be the one that receives the alignment rather than size. So it is just something I'll leave it at to do just for that reason. Perfect. So we're gonna partition this block, and what we do is first update the metadata of the left block. Yes, the footer must be fixed at the end. Yeah. So it is like a mistake that we've been making, not having it that way. So let's see. Let's finish partition block. We're gonna grab the left block, which starts as that's in the same address as the big one. And we're gonna update its size because now it's a different size. And the rest of the things sort of don't stay the same. The left and the right and all of that don't stay the same. They change. But the user is responsible for calling those after we partition the block. I guess I see the problem now. Because that means that not only do we have to insert the remaining guy. Oh no, it's okay because we perform a partition when we're actually going to use that block, so it's fine. It's fine. Just something to take notice of. Red black tree info in header is no longer valid for either block. Right? So that's something important that we shouldn't rely on. We'll see. Okay, because currently I feel like we're juggling between like trying to implement this function, then thinking of whether or not this thing should have access to the red black tree, thinking whether or not. So I'm gonna add that warning. We're going to try and decide, is this worth it? Like the separation of concerns that I'm proposing, is it worth it? Does it make sense? Okay, but first let's finish this function. And so we grab this as a block pointer, we grab the size, and then we make it the size needed. So this is the left. So your update left block. We update its size, but then we also need to update its footer. And the footer is going to live at the end of, okay, so we're gonna need a footer pointer, so block footer, and this thing goes here instead. And where is the footer of this block located? Well, it's located at the initial sort of step of the block, right? So here, sort of the size of wait. Wherever the block starts, plus the size of the user section of that block, which should be bk size of block, right? And now we should be placed at the footer. So, actually, no, sorry. There you go. Where is the footer of the left? Well, it's gonna be at this block plus the header. So it's just gonna be block is pointing to the first byte address of a block. We skip by the amount of the header, and then we skip by the amount of user data, and we end up in the footer. I think another to-do. I think it would be very helpful if we were to implement like, this is a to-do in the sake of style, right? Which is implement sort of footer and header sections or like functions so that we can just, call footer and then like be transported to that block's footer instead of doing the arithmetic all the time. So now Nick Versa, is partition block allowed to set the footer size? Yes, because it is responsible for partitioning the blocks. So once it partitions the block, it should make sure that the state after that partition is still correct, so that we end up with two blocks. So it has to set the footer size. Because we have this guy and then we have block plus size of the header, and that's exactly what we're doing right now, I think, where we're gonna access the size of the footer and hello. Oh yeah, make this a block pointer, sure. Block pointer. And then consider it not as a block pointer, but as a char star. And then we can access from here. Hello. I think we can close it in parentheses again. Yeah, and then we access its size member and we set it to be the size that was needed. Perfect, so that's the left block. Now we update the right block. Update the right block. Block. Okay, it's gonna be a block pointer to the beginning of that. So that would be block plus the total space left. So that would be the pointer to our right block. And for that right block, we need to update its size to be equal to the total space that the right is going to have minus the size of the potential block header that you're going to obtain minus the size of the block footer that you're going to have. Perfect. And so your state has two blocks with correct header plus footer, but not complete as the tree state is not updated. Yes. And that's what the red comment is saying, is like the red black tree info in the headers is no longer valid for either block. So that's why I said, like, I put this in red to consider whether or not my suggestion of separation of concerns makes sense. We're going to think about it after we finish writing the function. Let's finish writing the function and then sort of discuss, do we want to design it this way? Should it be the responsibility of keeping the red and black tree state correct? Should it be the responsibility of partition block, or should it be someone else's responsibility? I feel it's a fair point to question. So let's finish the function and then discuss about that right after it. Because block pointer, we have this, we have block plus total space left, and then size, and then the total space right. Oh, sorry. Isn't it like a bad color? Yeah. Let me make it green. Yeah, there you go. I think that's better. It's just that the red is like warning, right? It's like blood. Something bad is about to happen. And so that's why I put it as a warning. Let me put it green so that it's better now. Okay, now to update the right block, we go to wherever the right block starts, and then we update its size to be that. And I feel like we now need to update the header. And that one is a little annoying, to say the least. So we're going to have a block footer pointer, right? And what it's going to do is it's going to point to the char star of the block pointer for this block plus the total space left. So we're going to start at the beginning of the right block, and then we're going to skip the header, and also skip the user section. I know, I know. I'm gonna separate this into a bunch of variables. Yeah, don't worry. I know it is looking pretty horizontal and bad. Um, but let me just get it straight. So we skip the user section. We skip everything. Now we're at the footer. And now that we're at the footer, we can close here and then call size on it. So yeah, let me close, open here, and then close here. And then we should be able to access this as if it was a footer, yeah. Size, and then we're going to update it to be the red block size, which is, yeah, this whole thing. So I think like as I said, this is like really bad. And the comment we like I had placed before was like implement footer and header functions. Somehow something like this, right? Like the block member variables, so that we can like more easily interact with them. I feel this has new chat that yeah, the red you didn't read, yeah, remember set header, set footer. Yeah, yeah. For sure is like something we really need. So I think we can just do give me a pointer to the block header. We're just gonna call it block header. Access the block's header. And I'm just gonna pass you a block. And the thing that you're going to return to me is just a block pointer to that block, just reinterpreted as a block header. And then we finish. Perfect. And for block footer, we just need to do bk footer and then have a heap pointer to the block. Well, we're going to return, this one's a bit more complicated because we need to return something that conforms to a block footer pointer, and we start at the beginning of that block. So block pointer, then grab that block. We add to it the size of the header to skip it. Then we also skip the user data section of that, which would be block. And then we are at the beginning of the footer. So that would be it. And now I think that every single instance where we do something like convert this to a block header, asterisk, oh, there seems to be only one. I mean, that's fine. The problem is going to be the footer, where we actually need to have like, see 5 instances then. So here, right, where we set all of this, completely unnecessary. We just replace this with BK footer block. How beautiful. How beautiful. And this one we can just replace with block header block and size. I guess one way to do this is like the block pointer macro is over here, sure, but I think I would like to get rid of it and just use block header instead. So block pointer. Oh, I guess block header uses that. I think it's fine. I think we just like replace them. So this guy, right? That's what this is going to return. And then instead of X, it's just block. So that way now we can get rid of this macro, which is a little bit harmful. And whoa, whoa, whoa. Okay, I think I'm gonna move these guys to the top since they are sort of the most important one. Um, yeah. So now I say block header for that. And then here is we just say, well, block header size, block header left, block header left, block header block. Actually, why am I doing it this way? I think I can just call block header bk header in the replacement. Oh, sorry. There you go. bk header everywhere, and that should fix it. Yes, everyone's happy now. Great. So now that we have it this way, it is way more natural to update everything. Yeah, update the left block, update the header to be this size, and update the footer to be this size. It's like a very nice way. To update the right block, I think we can simply create like a little variable, something like right block, and just make it be the block plus the total left space. And then over here, we can replace both of these by just, right, for the header of the right block, access size, and then make its size be equal to, yeah, the total space right minus this much. Yeah, that seems fine. Right, look. And then here, all of this unnecessary thing just gets set to block footer. How beautiful. How beautiful. Yeah. Perfect. Awesome. It's way more readable now, which is great. And finally, after this, we return. Right. So you touched header partially its size. That's not right to me. You should set all outdated fields and set header. That mean partition will do remove and insert. Keep all updated in one logical operations, not updating later. Header partially its size. That's not right to me. You should set all the updated fields and set header. Use partition. Yes, yes, yes. That is what we're going to discuss now. That is that is the comment here, right? That like you update the header, but only the size, and then all other things are no longer valid, like the left, the right, the parent, and all of that. In the color, so those get like invalidated the moment you do that, the moment you change the size. So let's discuss, because the reason why I was advocating to keep them separate is this. Whenever you use partition block, which is used by partition if worth it, present in all of these places. So I'm going to grab one of them, right? Whenever we partition the block, we usually never want to reinsert the block on the left because we have already removed it from the tree. Right? So every time we call partition if worth it, we have removed the nodes from the tree. So the state with respect to the tree doesn't matter at all because they're already removed, right? And like, in fact, that's sort of the purpose, right? If you remove it from the tree, then it's like, oh, you're free to do whatever you want with that metadata because that doesn't even belong to the tree. If we were to include an arbitrary insert instead of partition if worth it, we would be removing it, putting it again, and then removing it immediately after, which just doesn't really make much sense to me on like why we would be doing that. Not only like does it take a toll on the speed of the program, since we would be doing a tree insertion, which for the sake of our malloc is the most expensive operation, We would also be doing a tree removal, which is once again the most expensive operation we can do. And so it doesn't seem like something we want. I do agree nonetheless that the fact that the state, so the fact, it's like after you do this, the state of the block is like not good, right? The state of the block is like messed up. But that's what's supposed to happen. And that's why we remove it from the tree before considering partitioning. I think, nonetheless, that you're right. We should sort of include a guard or like make it so that partition block can only be called on blocks that are not free. Or sorry, that are, yeah, that have been removed from the tree, right? And so that way, we're not worried about the state of the tree, updating it, or things like that. So we force ourselves to make sure that whenever we are updating the partition, it has to be a partition that's just not present in the tree. Um, I feel it's like the best of both worlds. We don't sacrifice the speed by like inserting, so to fix the state, and then remove, right? Uh, Can you not remove before partition? That is a great idea. But that is a great idea. Yes, you could. Now, I have once again the problem that like if you remove before partition, right? If you're like arbitrary remove and then you pass in the red black tree and then like the block that you want to remove, I have the problem that this is being hidden from the user. So instead of the function doing it for you, which could be catastrophic because, right, you're not accounting that, right? Like you're not relying on that happening. Maybe you try to partition a block that's inside the tree because you think like, oh yeah, this optimization, right? If I partition a block that is free, that is inside the tree, and then I keep it in the tree and whatnot, this remove is hidden from the user. Like we don't know this is happening. The function is called partition block, but it's also modifying the tree state. Instead, I would prefer it if the function, rather than doing your job, would tell you, brother, do your job, right? By throwing some sort of exception that makes it clear, like, you messed up. You should not have called partition block here. Because if we are calling partition block in a place where we shouldn't, which is the block is still inside the tree, if we have it like this, that error in logic is going to go silent because it gets removed from the tree and then the program continues. So I would prefer it if it just tells us like, bam, like you cannot do this. And the way to do that is actually fairly simple, right? We simply assert that the block is not free, right? Because that's the only way we can tell whether or not something is in the red light tree. So if something is free, it is in the red light tree. If it's not free, then it is outside the red light tree. And that way, we can guarantee that we always call this with a node that's not in the tree. So it is worth noting, nonetheless, that we have sort of a divergence in sort of like our thought process, because we usually think of and we use partition block whenever we want to partition free blocks, right? If you're trying to partition a block that's allocated, then you're like in big trouble because the user is still using that. Um, so we need to sort of differentiate between the two cases. Either this guy is a this is tough. This is tough. Um, Yeah, so either this guy, because if you call partition block on an allocated block, you are also doing something wrong, and we want to tell you about that. But in that split second where we remove it from the tree, our block is now considered um, allocated since it's no longer in the tree. But those are different situations, right? The time where I want to remove it from the tree and the time where it is allocated. Um, let's see. So what would realloc do? Well, realloc would be pretty simple. Realloc would be, oh my god, that's a lot more. Oh, it just works okay. Hello, how are you? Um, you mean like the code that we've written or something else? So I'm glad you're joining the stream. Yeah, welcome back. Hello, but yes, the code. Yeah. So we finished the whole red black tree thing and we moved to the actual memory allocator. And that's exactly what we're doing. Uh, as you can see, we have like malloc here and we wrote like all of malloc and we're in the process of writing malloc. We also ported all of the code of the red black tree to C because the memory allocator is going to be in C, and we also needed to change a little bit of things because our like our red black tree is going to be embedded inside the memory itself, like the memory blocks rather than the values, they are the nodes at the same time. And so we needed to make some modifications, but all of the code we wrote is over here just under a different interface, which took us some time, but we got through it. Now we're focusing on the memory allocator. So currently the concern we have, just to sort of update you on this, is that when we are serving a request for the user, it may be it is pretty possible that the only block we have available is like one huge block, right? Say this one, right? This block that's like 78 bytes wide, and the user is asking for only 44 bytes. So then what we have to do is we have to partition this block because we're not going to give them like this huge block to accommodate for such a small request. We're going to partition, and that is exactly what this partition block function does. And every debate we're having right now, or not debate, but like decision or key decision we have to make is what are the responsibilities of this partition block function and how does it behave? Because currently, how it's working, we are in charge of partitioning the blocks, right? We sort of perform the partition, right? Update the size and everything. But notice that now there's a new block, right? So this new block needs to be inserted since it's going to free also inside the red black tree. But now the partition block function is doing two things at a time. It's like partitioning, but also updating the red black tree. And the problem is that we in our program use partition block every single time for things that are not in the red black tree. So like, does it update its state? Do we just let it hide things for the user? Do we obey the name? What do we do? So that's the context of the discussion. Let's see. Nick Vorsi, you're saying realloc will partition or may merge or may free and malloc. Yeah, and that is completely fine, right? Realloc, because like it is completely fine in the sense that this is the responsibility of realloc, right? Realloc's responsibility is I'm going to grab this thing, put it somewhere else, and after putting it somewhere else, make sure that the overall state of the allocator is correct. I think the situation is different with partition block because partition block needs to be called with things that are not in the red black tree. So it shouldn't be responsible for updating the red black tree information since we already know that information is just bogus, right? It just doesn't make sense, since you should call it with things that are not in the red black tree. Uh, and so yeah, that's what I mean by separation of concerns. Like, partition block is not responsible for the red black tree data because you shouldn't be calling it if you still have it in the red black tree, right? Um, so yeah, uh, it will partition of allocated block. Mm, realloc or partition block. But yeah, while you type is it, so let's keep sort of thinking about it. I feel like by the fact that you must call partition block for something that you are about to give to the user, then that something shouldn't be in the red black tree. Um, if size gets shrunk, well, we cannot. Can we realloc? I guess okay. Is the specification of realloc uh does allow us to put a size that's smaller than than whatever was there before? After I haven't really used realloc. I usually just do the allocations myself. Like I just call malloc somewhere else and then transfer the data with like memcopy or something. Um so yeah, I haven't really used realloc. If so, either way, it doesn't really matter because, yes, it would also partition, and it is part of Realoc's responsibility to do that, right? It would partition, and then it would merge blocks, and it would do all of that. Um, so yeah, that's like right. So, guys, what's your thought on Elixir on Xlir Lang? Xlir or Elixir? Currently learning it and want to know if you heard or used it before. Uh, wait. Just to verify, if you mean Elixir or Xler, I think it's Elixir, but maybe there's a language called Xler, programming language. Yeah, okay. You probably mean Elixir. Yeah, there's not one called Xler. Haven't really used it. Haven't really used it ever. Nick Forza, do you have experience with Elixir? Um, maybe. Yeah, we have like a little break in between to answer both questions. Um, Because I've only heard of Elixir in like interviews and some people talking about it. Um, but really have much experience. There is a third viewer. If the third viewer wants to chip in, maybe they have experience with Elixir, and you can say it. But yeah, let's see. Um, so what you assert in partition, say in case of realloc. Yes. I feel like you're right in at like the same point that we were doing, right? That like if we put assert, and we say like, oh, you can only call it whenever like, right? This block isn't free or something like that. Block. Oh, sorry. BK is free. Yeah. So make sure that you only call um, partition block on blocks that are not free. That is, blocks that are not in the red black tree. So this would satisfy that, right? For our usual case. And for realloc, It would too, actually, because the block that the user passes to you is simply not in the red black tree since it's not free. It would also pass the assert and then everything would be fine. I am more or less concerned on the fact that there is a distinction of situations. So partition block in our mental model, we want the user to call it on a free block. Or like the programmer should call it on a free block. So you should only be able to partition blocks that are free. You shouldn't be able to partition blocks that are allocated, right? Because if you partition a block that's allocated, then you just like ruin all of the users' data. So we want to be able to say something like assert that the block that you're partitioning is free. The problem, if you partition a block that is free, it means that you're partitioning a block that's in the red black tree. And if you're partitioning a block that's in the red black tree, you're like updating the red black tree state and all of that, which is honestly not that much of a problem until you realize that that involves a removal from the red black tree, an added insertion to the red black tree, another removal, and then another insertion. So 2 times the removal, 2 times an insertion, 4 times performed the most expensive operation that we have in this memory allocator. So you shouldn't be doing that either. You should be doing that with a specific type of block. That is a block that is free and that you've made sure is out of the red-black tree. Only on that type of block should you call partition. So it is like, currently our program cannot distinguish between free and present in the red-black tree because for it is the same. Right? The program thinks it's the same thing. But yeah, I don't know. It is like strange. Like, partition blocks shouldn't put things inside the red black tree because once again, every single time we're calling partition if worth it, we are always removing from the red black tree. And so if we were to keep the red black tree state accurate, we would be doing a double remove from a red black tree. So like that thing doesn't exist anymore. Not only that, but you would be calling like remove and insert like 4 times, which is absolutely insane. Let's see. Why not? If I want to shrink it by realloc, I don't want to do extra work. Like, so before realloc, I must free, then malloc. So are you saying that like changing the way things are working, because I don't know which point you're opposing. Are you opposing the fact that I'm saying you should never call partition on a block that has user data that's allocated? So you're saying, oh, calling realloc, well, realloc needs to partition a block that's already allocated, right? And so I definitely needed to be able to call it on blocks that are already allocated. I'll consider that because that is like a valid argument. And thinking about that, I I guess that could be a valid reason, right? But it reinforces. Okay, so this seems more like a trade-off. It's like the cap theorem. No, you cannot have consistency, availability, and partition resilience at the same time, all three. What I mean by that is like there's a similar situation here where if you only accept free blocks, then realloc cannot use the partition thing, right? But if you're willing to allow realloc to use the partition thing, then it means that you're willing to accept that we shouldn't update the red black tree state, right? Because updating the red black tree state of a block that's allocated would be very catastrophic, right? Not only are you doing the fork calls, but also you're updating data that shouldn't even be updated. In the case of realloc, like realloc is like a double-edged sword because we allow partition to be called on blocks that are already allocated, which I'm fine with, but it's also an argument for why we shouldn't update the state of the tree. Because notice that realloc wants to keep the left block allocated, but wants to free the right block. So it is realloc's decision what to do after the partition occurs. There's no universal case where you say, yeah, this guy and this guy both should be in the tree. No, like malloc, when you partition with malloc, you want that to happen. When you partition with realloc, you don't want the left to be put back into the red black tree. So it seems like an argument for both purposes. so I'm willing to give in on, sure, let's allow partition block to be called unallocated blocks, but let's remove its responsibility from keeping track of the red black tree data and just trusting that the user will call it without this thing being inside the red black tree. So we can just have sort of the assert. So this assert would stay here, right? You can call it with an allocated block, in which case the assert is true, right? Make sure the block is not free. And you can call it whenever the block, despite being free, is not in the red black tree, which for the sake of our memory allocator are the same thing. And so this assert would pass. So the assert stays. I feel like it is the resolution to the conflict. It reconciles the realloc thing, and it reconciles the make sure this is out of the tree. Or cheat, don't shrink, just reserve the same block. I mean, yes, yeah. I guess okay. We're relying on something. We're relying on the fact that like, let me check. Like, can realloc shrink? Just I'm pretty sure if you're suggesting it, then when you pass the size smaller than the original allocation, realloc reduces the block size. Okay, perfect, awesome. So now I think this is the resolution to the conflict. I do have to say, the fact that we need to like the fact that being in the red black tree is the same as being free is fine until we reach this point. So we have to be very strong with our mental model, because in functions like these, right, you have removed this best fit block from the red black tree. So now the program thinks this block is allocated. But in our mental model, it isn't yet, right? Because we could just, right? Because we want to call partition on blocks that don't affect user data. So we just have to keep that in mind. I also think it's not that hard to grasp. I wish we could have it a different way, but since being free is equivalent with being in the red black tree, I think this is our only option. So just remember that. That's our mental model. Let me just add a comment. Thus, in period and then here. Thus, it is important that it is never called with a block inside the arbitrary. Perfect. I feel we this is a you know mutual agreement. Let's say resolving our differences with um yeah, that is pretty good. Um, Hi Arctic, how are you? How are you today? Thank you for joining. Yay! So welcome to the stream. I feel that since the last stream you were in, we've done a lot of stuff. So currently we are, yeah, yeah. Now we're writing the actual allocator. We're writing malloc now. We have finished writing malloc, um, allegedly, right? Because we haven't tested it, and that is just a synonym for saying like uh, it has a lot of bugs. We just don't know it yet. Yeah. So we have malloc, and we were just discussing about what this partition function should do. But I feel like our differences between me and Nick Borsa, which is the other chatter present, are resolved. So now we have our code, very pretty, very beautiful. Um, and so that's the thing, right? So we have that's the current state of the project. Right? Malloc is there, and yeah, we're coding in C now. We had to port all of our red black tree code to C, and not only that, since we needed the red black tree, and I remember telling this to you guys when we were writing the red black tree, since we needed the red black tree to be like embedded in memory, and that is to say, like each block of memory was not only the value but also the node of the red black tree. So there was no sort of like object to represent that node. Like the block of memory was itself the node. We needed to make some modifications, but all of the code we wrote, here it is, like present now, translated completely to C, and with a little bit of change in the interface because the fact that it is in C, but present. So yeah, a lot of things have changed, and we have made a lot of progress. Um, Not sure if Nagvorsi you're there, but um, I hope you agree that um, this is the good sort of like way, right? Like the good of the path of the Jedi or whatever. Like you know, this assert should go here, and then we resolve both of our differences through a midpoint. C is the best. See, I had no experience with C before this. Like, or the experience I had was very limited because I'm used to doing C++ all the time. I feel like I like the language. I feel like C has a clear direction of what it wants to be. Right? Like, I feel C++ adds a lot of stuff which makes it very beautiful in my opinion, right? Like, all of the classes and all that stuff. Um, the fact that C doesn't have that, it's like sad because then you cannot use things like the objects and all of that stuff. Um, but in a different sense, since it's simpler, that simplicity is like very beautiful. And like you now really need to think about like how you're going to code things so that they connect together in the end. And I like that. I feel like I'm starting to become a fan of C. So I imagine it's like your language of choice. You really C is the best. So yeah. Nick Vorse is saying yes. I am here thinking of for merging in Realloc. Oh, still merging in Realloc would be fine, because we once we get out of partition, we simply run the free logic for that same block. Um, yeah, I feel it's fine. We have no. Yeah, we wouldn't have much of a problem unless. Okay, so that is the thing. Like sometimes I say like, oh, I don't think we have a problem, and like in some specific occasions, like little like some occasions, you're like, oh no, actually there was a problem, and then I have to swallow my words. I think we're good for realloc. I think we can also think about it when we get to realloc, and yeah, yeah, that's it. Let's see. Arctic, you're saying in C++, it's more like you're trying to be clever and using the most idiomatic solutions and model language features. But since C is static, it's more about your creativity as a programmer and using the limited features. I feel like that's a good way to describe it. Yeah. Um, pattern of vector that push in loop requires realloc a lot. Yes, 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 yes. But what was I saying? That's why we want it to be the most efficient. I think having partition block not update the red black tree allows us to be efficient in that sense. So there you go. Another reason why we shouldn't change the metadata of the red black tree. I think realloc is fine. I think realloc is fine. We yeah, I'm not too worried about realloc. Oh, we forgot to update one of these guys. Block footer last block. Last block. There you go. Okay. So do we have more block footer weird things that move around and do random stuff? Yes. Okay. So we need to. Oh, this one's a little different. Yeah, this one's fine. Okay, perfect. Arctic, your realloc implementation? Yeah, so currently we have only coded malloc. We don't have realloc yet. Negvorza seems to be worried about something with realloc. I'm not sure I'm too worried. It seems to be like the merging of free blocks because we're thinking like realloc could also shrink. Um, and so yeah, right. And sadly, a lot of creativity ends up being unreadable macro hell. In C, I don't have experience like as much experience with C like to chip in. I think Arctic does. I do have to say, well, like we've been creating like a little bit of macros, although I feel these macros are like, you know, kind of decent. This is not too many macros. I want to think. Uh, so I assume you guys have seen like very bad things with macro hell. Um, but yeah, so okay, we have malloc. We have malloc, guys. I think so. Right now, everybody, listen. So, are we happy with our implementation of malloc? First, I think I need to solve. Wait. Give me a second. We first need to solve an issue in the header file for the RB tree. Hello. I think we're fine without this. Yeah. Perfect. Okay. Are there still errors in the C file? Let's read. Error while processing RB3. I just think it's just the extension is slow. I don't really write C, mostly just reading other C libraries. Pretty good. I once wrote an ALU in my. Whoa. Damn. That's crazy. This doesn't work in C, bro. RB3 T. Oh, wait. You mean this guy? Does it not work? Do I have to do this? Small macros can be inline phone. In the inline phone. And then, yeah. NK Writer. Oh, welcome to the stream. So yeah, let's see. Bro, I am contributing in open source. I built Postman alternative. This is faster than Postman, but I'm looking to sponsor. Can you give tips on how to get a sponsor? I am. I'm not sure. I'm not too experienced with this. Maybe somebody in the chat is. Um, it depends, right? Like, I'm not really involved in open source. Like, I'm just creating malloc uh, for learning. But yeah, if somebody has some experience, you guys can maybe chip in to answers make NK Writer's um, question. The function you deleted, you say. So, did I delete a function? What did I delete? What did I delete? Oh, you mean here, this function I deleted? Like because before we had this, right? And yeah, no. Like what I had was not going to be this. Like my plan was to be like, oh, pass me the pointer to like the root so that I can initialize the arbitrary with the root. But that's why it was an error. Like I just abandoned that function because I was like, oh, we're not gonna need that. So that's why I deleted it to be like, oh yeah, this we don't need anymore. But it is good to know though. I didn't know that. I was just I would have generally just returned the empty brackets. Is this initialization fine? I assume it is, right? Because this guy starts everything to be 0, I suppose. But yeah, okay. I think this is fine. Right? Let's confirm. Okay, we have everything. Never mind. Non-void function does not return a value in all control paths. Oh, you're right. We need to return. So since we are partitioning a block, we just need to return the heap pointer to what the right block is now. So we just return right block. Perfect. We have one more warning, and it's this one. Oh, let's just return 0. All right. To make it 0, you gotta write. Oh, okay. Interesting. Um, to make it like 0. Does this work? I know it works in C++. I forgot the rule. Yeah, it's fine because like for us, like we don't really need to set any value for this. This could just be garbage memory. We just need it to be something. And yeah. Oh, you gotta make it 0. Okay, so it doesn't work here. All right. Well. Oh, thank you for following. NK right there. Welcome, and thank you very much. We are now 21 followers, so we've almost doubled in followers since the last time Arctic was here, I think. Yeah. So, guys, listen. We have allegedly finished malloc, and that comes with like a great warning because once again, this is gonna have a lot of mistakes, like for sure. Nonetheless, it is our first iteration. And so, as a prize, we get to push this to the Git, to the GitHub. I think we have Git remote. Let me see. Yeah, I have it set up. Oh, Andrew. Let's see. Andrew. Oh, you're replying to NK Writer's comment. Pretty good. Thank you very much, Andrew. Let's see. Go and see how other people, how other open source projects did it. There are multiple paths. You can just ask for donations, like Zig, or you can make open source open core, but provide paid features on top, which don't really feed into projects. Otherwise, Data Store, for example, you can provide hosted solution on top of the core product. Types Grafana, I think, does the same thing like that. GDB, GDB is currently scared. GDB is hiding in the corner, waiting. Yeah, we are about to do unthinkable things to GDB with this code. Like GDB is gonna be, almost like in a prison while we debug the code. But it's okay because for now, as a prize, as I said, we get to push this to the GitHub. So let's go git add dot, right? And let's simply, uh, I think, what branch am I in? I'm in main. Okay, yeah, that's fine. It's only us, so we don't really need to worry about pull requests or something like that. So what we're going to do? Ooh, wait, we have uh whoa, whoa, whoa! Oh my god! I am Samir here. Hello, welcome to the stream. It says first time chat from Raider. I am Samir here is raiding with a party of 17. What does this mean? Uh, isn't rating bad? Is like I've heard rating is like dude, the only reference I have of rating is like when you raid like some sort of some sort of like dungeon, or when you raid like a village. When someone ends the stream, they can send viewers to another stream. Oh wow, whoa, oh my god! Wait, this is the first time. That means your channel is under attack. They're botting hack. All right, buddy. Um, yeah. Bring my viewers to watch your stream. Oh, thank you so much. And so yeah, I mean, welcome everyone. Welcome to the new people. We are currently writing a memory allocator in C, and that has been a process that has taken us around a week up until this point. Started on the 4th of July, so on Saturday. And right now we're implementing sort of the core functionality of the memory allocator, because before it was previous to this, we were doing sort of red black trees implementation in C from scratch. And now we were doing that because it's going to be sort of an underlying data structure in our project. And now we're actually getting into the nitty gritty of creating the memory allocator. I imagine. Okay, so just oh wait, let me see. Just saw your programming in C and thought it would be cool to watch. Thank you very much. So I imagine many of you will be familiar with what a memory allocator is. It is basically the guy that is in charge of managing your memory as a programmer. And this is the guy that is going to intercept your malloc calls and your free calls. And it's going to manage how every single block inside your heap behaves and like all of these things. It is a fun exercise. Didn't know that much about memory allocators before this. I am just a college student, which means like I don't have as much experience as maybe some of you guys that are, have years and years of programming. And as such, this stream is mainly intended to learn and to sort of do, to explore. Yeah, everyone here is really smart. Yeah, man. Like, we I think every single person that has joined the stream as a chatter has been like a great help when it comes to coding this, at least when it comes to like idiomatic things and like everything. Not for me though. That's completely fine, because like the one of the reasons why I started streaming, and once again I started streaming only 1 week ago, is for people to just join in and learn together, because I am in this position where I don't know most of this stuff. We are learning all of this, and like I find it just good if people join and they're like, "Oh, I don't know anything. Could you explain?" And then it's like, "Yeah, this is completely fine." So if there's something that sounds at some point confusing, let me know, right? To everyone that's joining in. It's also the fact that there are thousands of implementations like of malloc already out there. Malloc already exists. There's like jmalloc. There's thousands of memory allocators. But the reason why we do this is to learn, right? And to have a challenge, to have something to look forward to. And yeah, it is, I feel like, a good mindset we should have. Michael PC Gamer, it looks like you're in an office with a chalkboard behind you. Really? That's good. You know, it's like this is my bedroom right now. Temporary bedroom though, because I'm currently in an internship, and so after this summer I have to go back to school, and the room I have at school is like very small. So the background of the stream is going to be a little bit different. Enjoy this view while you have it because it's gonna be after like August is gonna be like super shrunk. Designing a memory allocator was an interview question I got before, so it's nice you're doing it. What, brother? What? What company are you interviewing for? Oh my god. Um, I feel like if I were to be asked, like, uh, yeah, write a memory allocator from scratch right now, I I would drop on the spot. I was just, I would say, I'm sorry, you guys, but no. Um, because like it's taken us once again a week. Like we've been coding for a week. The red black trees, the everything, and it has amounted to this. Um, Technically, a simple linear allocator is an allocator. Maybe. Yeah, yeah. Then you just tell them like, oh yeah, let's just create a linear memory allocator and it's free. Um, but let's see. It was the base case with just allocate and free. So okay, I'm very scared now. If this is the job market, guys, you know, maybe some of you already have jobs. I do not have one yet. I have once again just an internship, but I'm still in college. I've not even yet graduated. So if this is what the job market is looking at, like, um, yeah, I might as well start packing my bags to be honest. But so I have a question, Samir. You say that like the interview was it designing the memory allocator, sort of having doing the whole sort of what we're doing here, where we like do the drawings and like perform sort of a mental design and the infrastructure and the architecture of the allocator, or did they actually make you write the code for the allocator? Because I feel it is a pretty difficult question, the design, but it is a question that like you can do uh like would make sense for an interview, because we have like a overall view of what the memory allocator will do. But if they ask you to write the code, I feel that's like another level. Like almost like the system design interviews where they ask you like, oh, design Twitter, right? Is very different to say design Twitter, which is a pretty difficult question, but not as tedious. It's an entertaining question and it's fine and it's fun compared to like write Twitter, implement Twitter from scratch. Like that would be absolutely insane. So mutex lock kinda. Oh yeah, I've done one of the other projects I've done is like a little thread library in C++. So was it something like that where you have to implement mutex from scratch? That one's kind of fun. Um, I see Black Deep says just have your allocator always return null easy. That is, I feel that is the best strategy. Right? Just ignore the work. Also, companies believe that AI can do our jobs. Yeah, it is. It is the scary part. Um, don't even get me started on the AI. Like I was. Um, yeah. Well, it was even scarier when they thought we could do our job. All right, buddy. Mommy Jumala doesn't really help the morale of the group. But yeah. It's similar to this where we use vector data structure and keep track of some free indices. Oh, we have a. Oh, there's a legal question. Okay, let's. Actually, can we could take a look at this. Let's take a quick look. It's because I want to be contextualized to what you were talking about. Um, let's wait. Um, Design a memory allocator. Okay. You're given an integer representing the size of a zero-index memory array. All memory units are initially free. You have a memory allocator with the following functionalities. Allocate a block of size consecutive free memory units and assign it the ID MID. Free all memory units with a given ID MID. Okay, now that multiple blocks can be allocated to the same MID, you should free all the memory units with MID even if they were allocated in different blocks. Implementing the allocator class, allocator intent, initialize an allocator, allocate, find the leftmost block of size, consecutive free memory units, and allocate with the ID MID, return the block's first index. If such a block does not exist, return -1, and then free all memory units with the ID MID, return the number of memory units you have freed. Okay. Okay, this makes more sense. This makes more sense. So our memory allocator uh, decided to sort of diverge a little bit, especially in this part. Um, there is policies for allocation, right? First fit, next fit, best fit. We decided to do best fit. This one, interesting. But yeah, this seems like an interesting question to have in an interview. Um, I was worried they were gonna make you do whatever we're doing, and it would be. I feel like if they ask us to do whatever we've been doing on stream, the fact that we've spent like 1 week, I'd be really scared. But yeah, I hope it was. I hope the interview went well for you. A little harder in the interview, but not as difficult as when you're doing it. I, I mean, you have to account for the experience. So, yeah, but yeah, hopefully this is like a good exercise for us to really put our minds to work. You can do a free list allocator. Yeah, yeah, those are relatively easy, I guess. Just a linked list. Yeah, I mean, relatively easy. Like in the overall scheme of things, maybe, but like, yeah, it's still pretty difficult. Jacob says hi. Yo, hi, Jacob. This is much easier than what you're doing, so you're good. Oh, that's good. What's happening? Hi, Jacob. Well, currently we are coding a memory allocator from scratch in C. The memory allocator, the guy in charge of managing your memory as a programmer. And we have settled on a design. The design refers to sort of how we're going to organize our memory. You can see it right here. We're going to separate memory into memory blocks, and we're going to store some metadata. And then the user's data is going to be in this little section. Um, it will be a memory allocator that could hopefully replace calls to malloc. We will see, right? We'll try that out eventually when we build it. And we have spent a lot of days, like around 4 days, trying to code a red black tree. We did that, we finished, and the reason why we need it is because it's the data structure we're going to use to find free blocks. And right now we're just writing the actual nitty-gritty of the memory allocator, which I'm very happy about. We finished writing malloc. Finished is a little bit of an overselling point because we haven't tested it yet. We are going to test it. But as I was mentioning everyone as I was telling everyone, since we finished malloc, we get a prize, and that prize is we get to push this to our GitHub. So everybody, right now, from those of you who have seen the development, and also if any of you guys, like the new ones, want me to explain what we've done, I'll be more than happy. The reason why I say that is because like I could explain the code but it would take us a long time. So if you guys want to spend time sort of understanding what we've done more in detail, let me know. An overall view of our memory allocator is we're going to perform lazy initial allocation. That is, whenever it is possible that the programmer never uses the heap. And so in that case, we don't want to start putting stuff in the heap that we as the allocator need, but that the programmer will never actually care about because they never use the heap. So lazy initial allocation just refers to that. We actually initialize everything in the heap. We actually initialize everything in the heap on the first call to malloc. And so this is the if that you see here. We introduce some padding so that everything inside our memory allocator is 8-byte aligned. because it's a requirement for malloc. And we create a little ghost node that's going to, it's, don't worry too much about it. It is just an artifact to store a red black tree. This is basically, when I say ghost node, it is just, the root of the red black tree in a sense. Why am I mentioning red black tree all the time? Well, we are using the red black tree, as I mentioned, to keep track of our free blocks. Red black tree is just some type of binary search tree. And what we do is we keep track of the free blocks by inserting them into the tree. So whenever we want to search for something, we simply pass in a size and navigate down the tree, just as we would in a binary search tree, until we find a block that can fit the size that the user requested. Now, that's exactly what we do over here, where we say, okay, find me the best fit block. So then we do arbitrary find. If we actually found something, remove it from the tree, and enter this sort of decision tree where we say, it's possible that the only block that was available is a huge block, right? And the user only requested, say, 8 bytes. So it's not like we're going to give to a user that requested 8 bytes a block of memory that's this big, right? We need to partition that block of memory and give the user a more digestible size. So that's exactly what we're doing here. Calculate the space we need, partition if it's worth it, and if we actually partitioned it, put that remaining space into the red black tree again to mark it as free, right? And finally, we just return the thing to the user, right? Now, if there is no block that can suffice a request, we need to expand the heap. And all of the code you see here is precisely that, right? Trying to calculate by how much do we need to expand it and actually expanding it. Once we have done that, we're going to get that block out of the red black tree because it's no longer free. Then we update the header to have the size that, because we expanded it. So now we update the header to say, oh, this is the new size. And now you partition if it's worth it, you insert back into the red black tree, and you give the user whatever you found. So malloc logic is relatively simple. We coded it between yesterday and today, so pretty fine. Something I'm realizing right now is the fact that partition if worth it accepts the user's size rather than the whole block size. So let's just pass in that, and let's pass it in to the other call that we have, where block size shouldn't really be block size, it should just be size. Perfect. So also, oh wait, more messages in the chat. Yay. Sharif, I have a friend who is writing a game engine, and he was asking me about how to get contiguous physical memory. And I did some research. Actually, with regular syscalls and functions like virtual alloc and macBoFile, don't really let you do that. But some older engines came with their own kernel driver to allow them to do stuff like that and reduce the overhead of allocation. That is kind of insane. I imagine you are not allowed to do that because, like, the operating system, right? It's like the one in charge of virtual memory paging and all of that. That is interesting. No. But yeah, wow. Like having an online translation that allows you to a kernel driver that allows you to do that, it's kind of insane. I feel like I've mentioned this too in the past. Surprisingly, the people that work in like game engines and games in general have a field that encompasses basically all of the low level part of programming. Like if there's something that you need that is low level in programming, hire a game engine maintainer or a game engine person, because the lengths to which the game engine people go to optimize everything because they need it, right? Like it is a necessity, and like resources and etc. it's just incredible to me. And like many of legendary programmers are actually people dedicated to game engines. Yeah, so it's very awesome. Um, I remember the calculation for the inverse square root of a number that was present in the Doom code. You also have people like Casey Muratori, right? So it is very interesting to think of. You can ask OS to allocate page in specific area. Yeah, but then you would only be limited to the size of a page, right? You continue. Pages are not guaranteed to be contiguous only with, yeah, exactly. What Arctic is saying, I think would be, yeah. So I would be intrigued why we like why maybe you can respond to Arctic, like why does your friend need to allocate everything like together in physical memory? Because RAM is supposed to be created so that random access is supported, right? Like so that it's faster. I'm not sure. Maybe, I'm completely ignorant in terms of hardware, so maybe there's someone in hardware that can actually answer this question. But if RAM is designed for random memory access, then it should be fine to have things that in physical memory just don't live in the same place. Um, so yeah, welcome to everyone that's joining the stream. We have 19 viewers right now. That's insane. Uh, Before today, the peak of viewers we had was 9, if I remember correctly. We had it for like 30 seconds, but yeah. I don't know. Let's see. I assume RAM was not good at random access previously. Sure. I mean, you know, RAM, random access memory, not being good at it. But yeah, I would assume so too. Tell your friend to make their own OS, then they will be able to avoid the overhead. Surely it's always faster if you can make it contiguous. It is one of those things that, like, I feel it seems intuitive, but it may not actually affect anything. Um, and there are a lot of cases like these in like all over programming. I think one of them could be with switch statements, if I'm not mistaken. I think there is the suggestion that you should always use the switch statement whenever possible instead of a chain of ifs. And it seems rather intuitive, right? Because you would have a jump table and etc. But compilers actually account for that case, at least in the majority of cases. And they just use a jump table to, if you have a chain of ifs where the cases are determined. So like things like that, right? Where you're like, oh no, this surely works this way, and surely if we make it this way, it's gonna be better. And then you end up, you know, getting no benefit or anything like that. Um, Hi, Codox. So Codox joined or sees 0D0X. I imagine like Codox. I'm gonna call you that. At some point, it's not fitting into cache in a way. That is a good point. That is actually a good point. Like, worrying about the thing being continuous in physical memory, maybe a different. But we never know the use cases though, and that's something we have to be very careful about. Because sometimes, well, first of all, we don't know when this game engine was being created. Only Arctic knows. Um, and we also don't know the circumstances in which it was being created. So let's see. Probably just because streaming data from contiguous memory is faster. Page cache doesn't really care about it being continuous in physical memory. Yeah, exactly. So that was kind of the the point that was like, oh, like, page cache doesn't really care about it being in memory. So either way, if it's something that's big enough so that it doesn't fit in a single page, then page cache should be your first concern instead of trying to make it contiguous in physical memory. But I feel it's just the fact that we don't know enough about what they were trying to do. Let's see, this is what he told me. The idea is you can have your physical memory on fixed size chunks, but they don't need to be contiguous or anything. but they can be treated as if they are. Yes, that's the whole concept of virtual memory and etc. This means that the only kind of fragmentation that can occur would be like when you go to allocate a page or something. Yeah. Yeah. Hey, sorry if this is not a question, but I realized something this morning. Malloc can give you a block of contiguous virtual memory, but it's not guaranteed to be contiguous physically. If the physical memory isn't contiguous, would it be no different than calling malloc once per allocation, rather than calling it once for a big allocation and partitioning that memory for each thing that needs it? I think I understand the question. Let me read it again carefully so that, let's see, malloc can give you a block of contiguous virtual memory, but it's still guaranteed to be contiguous physically. Yes, agree. If the physical memory isn't contiguous, would it be no different than calling malloc once per allocation, rather than calling it once for a big allocation and partitioning that memory for each thing that needs it? I don't understand what you're trying to say with that part. I think is what you're trying to say, calling malloc for like the entirety of memory that you're gonna need in your program, and then sort of making sure that you keep track of where you store the things, sort of dividing that space that you big malloced, compared to calling malloc for every little thing that you need. I feel there is still a difference. Like, I guess, we kind of know the answer because, like, in the real world, applications that need a lot of speed and that are, need to be very reliable when it comes to velocity do actually pre-allocate all the memory that they're going to use. So I feel like it is, let's see, but it's not guaranteed to be contiguous physically. It is not guaranteed to be contiguous physically, except in the, at least as far as I know. If I'm saying something that is like completely sacrilegious, let me know. It is guaranteed to be contiguous physically, but only up until the size of a page. So I think we agree on that. If the physical memory isn't continuous, would it be no different than calling it once per allocation, rather than calling it once for a big allocation of particular memory for each thing that needs it? No, I feel there is still an advantage to just calling the big malloc. I'm not going to look at the comments. Let's see. I'm going to try and guess what the answer is, and then we will look at the comments of the people that actually know. But I imagine that it's the mere fact that every single time you call malloc, right? If you do it in separate allocations, like an allocation for each thing that you want, there is no way for malloc to know how much memory they're going to need. So at some point in time, malloc is going to perform a system call so that DOS provides a new virtual memory page. Because malloc cannot like directly play with the virtual memory pages, the OS is in charge of that. So the OS is the one that has to give malloc the page that they need. And that's sort of, I imagine, what memsbreak, sort of the role that memsbreak has. But if you do a big allocation, then malloc knows, okay, I need like to allocate this much space. So then the syscall that you perform is a single one where you ask for the amount of memory that you'll actually need. And the operating system is going to give you the pages that, or the amount of memory from the start. And thus you don't incur in like as many syscall overhead as you would normally. So that's my guess. Let's see if that's actually the correct answer. So Andre responded. It says, malloc internally does this partitioning anyway. Reason to do it yourselves is what you know your usage better than malloc developers. Yeah, that's true. If you want to learn more about RAM and what causes access to it being fast or small, you can check this recent article. They try to make it as low as possible. If you what? If you want to learn more about RAM and what causes access to it being fast or small, you can check this recent article. They try to make it as small as possible. That is such a funny concept. I think we can just let me take a look at this article. It's like yeah, guys, to see how it's like they're doing the exact opposite of what you would want. Um, Vining. Let's see. This seems like a pretty good article. Okay. I'm not sure if I mean depends. Like if the people want to read it, we can read it. I'll add it to my bookmarks. I've been reading some of the articles and the things that you guys have been suggesting. I was looking at the SN malloc for Microsoft that you, Andrew, and Siktenik were or Sinkenik. I don't remember the name, the specific name. Stricknade suggested yesterday, just looking at sort of the description and everything, trying to not look at the code because we haven't finished ours. Although this is like a completely different allocator, right? But yeah, I save these things. I think it was asking more in the sense that is the block you get more or less contiguous in physical memory, but I think it doesn't matter. Yeah. Check this, you'll find it interesting. So we found, oh, we have hardware drivers. What are we doing? The MML continuous memory allocates a range of contiguous, non-page, physical memory and max it to the system addresses space. What? It's interesting that out of all companies and operating system, Windows is the one that has this. I feel like this is a very like Linux thing though. Like somebody that uses Linux would be like, bro, we need a we need a function to actually et cetera to make it more versatile. Because this needs to run everywhere. The fact that Windows actually cared is kind of funny. Yeah, read it, man. Let's see. Yeah, this one's a little bit shorter. Let's see. The syntax is this: number of bytes, the size in bytes of the block of contiguous memory to allocate, highest acceptable address, the highest valid address the caller can use. For example, if a device can address only allocations of the first 16 megabytes of the processor's physical memory, the driver for this device should set highest acceptance rate. I don't know. If you do not have specific requirements for memory allocation, set to max Unix 64. Okay. Returns the base virtual address for the allocated memory. If the request cannot be satisfied, the routine and returns null. This is interesting because I'm trying to think, because does this break? I feel at least this is like the feeling. I feel that this would break the entire virtual memory model that we have, because now you have to have this special kind of address or special kind of page, maybe, because like now you don't need the page table, right? Now you're gonna be like, oh, this guy actually, well, what am I saying? No, you could just okay, no, integrating this would be tricky, but not as hard as I was making it seem. It is nonetheless interesting. I wonder what the use case is, because we still don't know. Like, why is it that we need this to be sort of contiguous in physical memory? It would make games quicker, actually, because I'm pretty sure that the CPU is faster at reading data from contiguous memory. Oh, okay, that explains more. Um, you don't learn where it is in physical memory, so it's okay. Yeah, for sure. You have to make your own allocator implemented as a driver. Yeah, okay, that makes sense. That makes sense. Pretty good. 18 viewers, dude. These are numbers that I've never seen before. Thank you for following. Wait, I am Samir followed. Same for Athena Geek, or like Athena GG. I don't know. Let me know if I'm pronouncing it correctly. And Zero Visible also followed. So thank you guys for 25 followers. Oh, dude. Yeah, brain damage. Oh my god. Staring at a screen for so long. Yeah, Athena J. Yeah, that makes a lot more sense. Yeah, welcome everybody. We took a little detour. I feel like it's always good to have these like conversations. We were coding the memory allocator in C, right? And actually, yeah. Wait. Okay, my friend has been working on Volcam and game engine for like 2 years. but he rewrote it like 5 times. That's absolutely insane. He would love your streams. Thank you, thank you. Tell him to join. Tell him to join. Then he can tell us about like what he meant with the physical memory. I feel like you gave already the explanation, right? That the CPU may be faster at accessing contiguous memory. Um, but yeah. I don't know. So yeah, wait. Yeah, okay. All right. We sometimes stop. Right now we have one goal. That goal is what do we name the comet for malloc? Because I told you guys like once we finish malloc, our treat is going to be being able to push this to the GitHub repo. So how do we comment this? So it's gonna be like a feature, maybe feat, and then like initial malloc implementation. So I don't know. Do we agree on this? What is the thing that they say at weddings? I'm not originally like English is not my original language. I'm not from the. I'm currently in the US, but I'm not from the US. I don't. So sometimes, forgive me if I ask like dumb things about English, but there's like this phrase, the thing that like the pre says, right? Like shut up, like no, what is it? It's like speak now or like shut your mouth forever, something like that. Um, I think I should just look it up. Wait, let's look it up. Uh, um, um, let's see. Well, I'm not from US and not in US, so it's not for me to answer. Oh, speak now or forever hold your peace. I see. Like, um, speak now or forever hold your peace. Held a message for a reason. Sex-based terms allow will post it to chat. Oh yeah, no, don't worry. I think the fact that you wrote it, hold your peace, like the moderator bot thought it was like something, not family friendly, but it's okay. Um, okay, forever hold your. Okay, speak now or forever hold your peace. So guys, speak now or forever hold your peace. Is this the comment that we're using? Semantic comments, nice. Yeah. So I don't know. It's like I haven't been used to that. Scoped comments greater than semantic comments. What is this discussion? This seems to me like the editor's discussion, Vmax, Emacs versus Vim, and like VS Code. What are scoped comments? Because I know conventional comments, which is like feature, fix, refactor, style. Um, Let's see. Scoped comments is a loose standard for formatting comment messages that focuses on making the comment log quickly understandable to contributors. Normal comment messages should be formatted as follows: scope, description, then optional body, and optional trailer. Scope, the subsystem, area, or module the comment touches. Description, a short description of the. Oh, okay, I see. So this is an alternative to. Yeah, I feel the examples make it pretty clear. Interesting. Oh, I meant scoped comments. Yeah, scoped comments better than conventional comments. Yeah, I don't. I don't want to hold my peace. All right, buddy. uh, all right, it's gone. Nobody complained. So I think we're just gonna push that one. Um, I don't know what the hell is scoped comments. Yeah, me either. So oh, this is pretty cool actually. You might use this. My comments are random, not gonna lie. Yeah, I try to keep it organized, right? It's the personal project, but like you gotta convince yourself that like, nah, this project actually matters and we need to keep track of the Git, like create branches for it and so on. Yeah. So okay, I think it's already pushed. Yo. I guess is what type of change is not actually as important as scope of it. 24,000 insertions in a single comment. Um, You're right. What the hell? Why do we have 23,000 insertions? Um, guys. Guys, I did a little bit of coding off camera. Yeah. While you were not looking. I don't know. Yeah. We also didn't vibe code anything because I'm a little bit against the use of AI when it comes to these projects. Not a little bit, very against the use of AI when it comes to personal projects that are aimed at learning. What was it? Why don't we have 23,000 insertions? Did you accidentally add some binary file? Oh wait, a teenage X says trillions will depend on this shortly. Yeah, when the apocalypse of the technological world comes, there's only going to be one memory allocator, the best memory allocator. It's gonna be this one. But yeah, no. Let's see. 2026 vibes. Yeah, this seems like a comment that you would have from a vibe coder. So, you should have used gift status. Did you know that I get ignore? Oh wait, no. I think I know the answer. I know the answer. It's the Excalibur. It's the Excalibur. Because we've been doing like all of the drawings and stuff, and like the Excalibur is technically just a file. It's like a huge JSON file. Like if we open it, I think if I open it with text edit or something, yeah, it's like thousands of lines describing what the drawings are. Uh, okay, there you go. That's our 23,000 insertions. Mystery solved. Yay. Okay. Let's see. Isn't it like SPG? Excalibur is just JSON. I did export it to it. Yeah, lol, LMAO. Git ignore is very important. Okay, so do we... Yeah. That's exactly what I was proposing. Like, honestly, we should just keep the Excalibur because, like, not only it's like a little capsule, right? It's like a time capsule. Nobody's going to understand this. Like, program. And then just like this little drawing. We come back to the repo like 10 years after, and this is gonna be like absolutely mysterious. Like, why is this guy smiling? Right? But it is a good thing to keep, a time capsule, and it is a sort of documentation. It is a very bad documentation, but I feel like you could recover our mental state depending on what you look at in the drawing, right? Um, parent, and then a bunch of zeros, and then an arrow goes out and an arrow goes in. This is, I don't know. It's kind of interesting. If only there was a decent Git client instead of opaque command line interactions. Just maybe seeing it as a Git LFS. Yeah, little ghost. So Git LFS init or a Git LFS install. What is Git LFS? The CLI is fine if you use it carefully instead of doing stuff like git add dot. Mommy Jamala. We maybe the CLI is fine unless you're one of those stupid people that use git add dot all the time. Yeah. Let's see. Large files. Oh, okay. LFS stands for large file storage. It's for binary files. Okay, I see. Better than 10,000 lines of Claude comments where you have no idea or hint what the human's mental state was. That is true. But basically what it does is it doesn't track individual changes as if it was code. Oh, okay, so it simply uploads the entire file. It just doesn't keep track of diffs, I imagine. That's like the only sensible way to design it. I don't know. But yeah, because we may just use that for the Excalibur. You can write in .git attributes file, Excalibur, diff equals no diff. Oh, really? If we can apply that right now, because I feel like installing Git LFS, I would need to like learn more about it to know how to use it and not seem like a clown here. If we can apply that as a temporary solution, Git attributes, and then we can do like right everything that's Excalibur. Just make its diff be no diff. I feel this is fine. Sure, let's follow your recommendation. I didn't know about this. GitLFS is more for .so files, for example, or other types of binary files. Yeah, I imagine, of course, if you're gonna have binaries, it's gonna be like absolutely insane to upload that to GitHub. Actually, under solution seems better. It seems like a good temporary solution, and like if we were to have like a more serious project and everything, we set up GitLFS or something. And so yeah, pretty good. So great. I don't know. Yeah. Okay, guys. Well, all right. Focus. Lock in. Okay. So we are here in our memory allocator. We have malloc here. We have the red black tree. Everything. It's fine. It is, as you can see in the top right of my screen. It is 10:38 for me. I usually go to bed at 10. I know. Getting a little old, so gotta go early to bed. Not, yeah, I usually go early to bed, but streaming has been like kind of like very fun and like doing this project that I usually have stayed up until midnight. But I have to go to like the internship tomorrow and whatever, so I cannot stay here all day. We we will start tomorrow with the implementation for free. I feel that that would be the more sensible way to do it. And potentially we will get to realloc. Free shouldn't be that bad. The only sort of tricky thing that we need to worry about is about like the block coalescing, where we to prevent fake fragmentation, where we have like we free this block, now we need to merge them. So yeah, we can implement that tomorrow. I think we're gonna call the stream here. Also haven't eaten, so I have to eat. Yeah, that's mainly it. I really actually enjoyed like talking to you guys a lot. I feel like we should dedicate like a little bit of the section of the stream to like talk. Well, I guess maybe we didn't do that much before because there weren't that many people. It's easier when there's like so many people, like 11 people right now. So yeah, to everyone that is new to the channel and new to the stream, thank you for showing up. To those that have been since the beginning, even more thank yous because yeah, you've seen the entire journey. Tomorrow, I think we'll continue with it. I think I'm gonna stream tomorrow at the usual time, which is like 6:30 p.m. for PST time, Pacific time, between 6 and 6:30. Okay, because that's like the moment I get home after whatever, after work and all of that. And yeah, thank you very much, guys, for being here. I don't know, unless you want to talk about something. Seems like you need to execute this for it to really work. Oh wait, yeah. Let's set that up before we. Let's see, git config. No. Oh, sorry. diff.nodiff.command, and then /user/bin/true. Great. Well, we'll just hope that did it. And yeah. See, bye. I never really used it myself. Brother. What do you mean? You just gave me some esoteric command. This is gonna. No. You're fine. Like it makes sense. It seems legit. It seems like the way you would do it, but it's so funny. I'm on Jujutsu VCS, sorry. Wait, what does that mean? Uh, you just said like words that are just uh Git is way behind me already for 2 years. Oh, version control system. Okay, I assume. Jujutsu? What? Oh, in Rust? Wait. Okay. JJ. Jujutsu, a version control system. Interesting. Oh, the description is a little bit long, bud. Wow. Okay. Yeah, we you learn something new. Um, I feel like this is a moment similar to how children in their early development stages don't have a concept for a theory of mind, where you like sort of experiment where you have two cups and then you have a ball, and then you hide it, then you let the person that did this, get out of the room. The kid sees they leave the room, sees that another person enters and swaps the cups. And then when the other person returns, right, the kid should be able to identify the fact that the other person is going to think that the ball is still in the cup that it was left when they left. And okay, that's a really complicated way to explain it, but that's what a theory of mine is. I feel like this is one of those moments for me when like you realize there are other consciousness in the world when you're like 4 years old. Like, it's like, oh, there's something beyond Git. Kamala is great. Git is way behind me already. All I just is to modify the copy file. Bro, why? You can use it with Git. I'm gonna start using Subversion. Many cool people use Jujutsu, but I haven't been convinced it's worth the switch yet. I wish Source HUD supported darks. Okay, I see. I did know of like other version control systems. Never mind. I know there's one that Facebook uses. Or Meta, I guess. Um, that was the one that was present before Linus Torvalds created Git and whatnot. So I guess it's like not as bad, but like this is a little bit impactful that there's like stuff that people use that's just different from Git. And it's just the fact that Git was the most popular. But yeah, I don't know. Um, Sapling, fossil, mercurial. Whoa. Okay, I feel um wow. So do they just accommodate for like different needs? Is there like a specific reason why? Hmm. Let's see. Jujutsu is unlike most other systems because internally it abstracts the user interface and version control algorithms from the storage systems used to serve your content. This allows it to serve as a VCS with many possible physical backends. Oh, okay. This seems like a pretty good reason. Stick with Mercurial. It has good tools. Basically, simpler UI. Okay. Hmm. I imagine simpler UI. You mean like the reason why other version control systems exist. But yeah, wait, this is pretty good. Oh, I saw it at Google.com. Ooh, so this was created by a Google engineer. Wow, pretty cool. Yeah, like the reason for JJ existing. Yeah, it has a simpler mental model. Interesting. Interesting. I'm not sure what can be simpler than Git. Well, I feel that implies that Git is simple. It kind of is for people that like really understand it. Actually, today I was learning Git. I was like on this little website trying to play with like um there's this very cool website which is like learn Git something command, learn Git branching jet.js.org. Um I felt like a kid again, playing and like trying to do all of the exercises. Um, it was very fun. It was like git check out and then like C2 and then like, git come in and you have to get the tree to look something like what's on the right. Um, I was doing that today at work. I know. I just admitted to not being in my full capacity when working, but sometimes I get a little bit bored. And since they force me, in a sense, to use AI, I have to use AI. So then I just, and I mean, while I wait for Claude to finish, I just do interesting stuff. Let's see. So Google and Meta each develop their own VCs for their stupid monorepo that are sort of too big for Git. Yeah, that makes sense. Okay. Interesting that that's the reason. So at that point, why keep it a monorepo, right? If it's like big enough to the point that you say the usual tools are not useful enough. So well, I guess let's let's switch to the scene because like we're not doing anything with a computer now. What would you complicate your brain? Well, actually, I prefer this one. I prefer this one, right? It makes us seem like we're doing something. So, um, why would you complicate your brain with new version control? That is honestly a legitimate question. Um, except for the fact, like like those companies, sure, they have the need, right? That's why like Darks 2 has a simple mental model in Git. If you have a good GUI, you don't need a mental model, but Git wants you to Google command line commands anytime you want to do anything. Yeah, that makes sense. 2 words, JJ undo. Ooh, that feels like a pretty powerful argument. When you're in like the middle of rebase hell, just being able to say, go back to whatever we did. I messed up. It would be a pretty good, nice addition. Um, pretty cool, pretty cool. Mhm. Yeah. Also, Andrew, why are you still awake? Dude, it's like what? It's probably 8:49 a.m. for you. You did not sleep at all, buddy. Like why? Um, that's interesting. You're a machine, Neuro. For context, Andrew, I think Andrew, you didn't sleep, right? Because currently, like a few hours ago when we were streaming, it was like 6 a.m. or 4 a.m. where you were, and now it's like 8 a.m. probably. Yeah, downside of JJ is what they don't have good UI yet, but using it from console is pretty pleasant. Pretty good. I mean, I feel like it has a better UI in the terminal sense, right? It has like the little dots connecting, a little progress bar. Oh my god, it illustrates the branches too. Oh, that's pretty cool. Okay, if it illustrates the branches, it might actually. I kind of see what you guys are saying with like Git not having an intuitive sort of layout or way to describe things. I feel like I would like Git to look exactly like um the thing I just showed, this Git branching. Like if you were able to just visualize your entire project as whatever this is, right? It'd be so fun. It's like you'd be able to actually understand, like, oh, okay, we're here, right? We're here. We need to move here. This guy needs to go there. So, yeah. You can also create branches without giving them names. Branches in JJ are only really needed to interoperate with Git. Oh, so JJ just doesn't have branches at all. What? Um, I feel like you're trying to explain the fourth dimension to a three-dimensional being. I cannot imagine a version control system without branches, and I think that's a problem. Um, but I'll have to read more about JJ. Let's see. Tortoise HG screenshots that. What is this screenshot? Let's take a look at it. Oh, wait, that's so pretty. Oh, yeah, like seeing something like this would be way nicer. Is this compatible with Git or is it for like Mercury or something like that? Mhm. No mention of Git so far. Oh, Mercurial. Oh, okay, I see. So Mercurial has the actual UI, and I feel it's a pretty good advantage. Okay, I see what you guys are saying. Um, JJ is inspired by Darks. Darks does that. Well, partially inspired. So what? So Darks is also another version control system. Damn, didn't know there were not many. Let me take a look at a picture of Darks. Darks VCS. Distributed VCS? Okay. Oh. Does it have a graphical interface, lazy schemer? Does it, you know? Um, most of the things I see are like pictures. So maybe it does, maybe it doesn't. Um, interesting. Okay. Partial inspired is just like a label for comments, but comments themselves can be made anywhere you want, independent of bookmarks. I see. There's a tortoise gate, but it's kind of janky. Yeah. I like Sublime Merch. It works with Git. I've been trying to use Source Git, but it ain't what I want it to be. No, Git has many GUIs. I use this one. Oh, so it's actual GUIs. I guess I'm stupid for thinking there wasn't, because it seems like a pretty good problem to approach through a product. Um, Max Air. Um, Managed walkthrough. Let me look for the. Wait, so do you use Emacs like to code? I feel that's Oh wait, yeah, it has like a terminal little drawing of. Oh, that was kind of cute. I feel like I like it when the applications are in the terminal. It makes you feel like more. Makes you feel like you know more. Emphasis on the feel. Like, but I like personally I like it because of that, right? It looks very like hacky. Sublime Merch is pretty good. Sublime is a good editor, by the way. Yeah, Sublime Text. You can also just run git log graph decorate. What? What? Sorry, git log and then graph. What? Is this real? What? Wait. Git checkout dash b test. Oh god. I wrote T set. That's fine. So if I run the command, it's fine, yeah. And then if I like make some sort of git add and then like git commit, whatever this is, so test one. Yeah, because it hasn't diverged from main. And now if we git checkout main and then we make a commit in main. Well, no. Well, I guess I'll just git add and then git commit dash m hello. Are we? Oh, I guess we haven't modified anything. So let me just make like a little dot in this calendar. There we go. Now we have something to add. And then we comment hello. So now if we do the graph, will it show it like different? Oh, it's the log for. Wait, I'm not understanding. How are we supposed to use this? Git checkout. Let's check out the other branch. Tset, and then if we run the command there. Oh, I thought it was gonna have like all of the branches and stuff. Okay, maybe I'm not using it correctly, but well, all I know is we have damaged the state of our of our repo just because I wanted to take a look at that. Um, okay, so I think we can simply git branch remove. I feel this is feeding one of you guys' points. Command to remove a branch using Git. I forget which one is git branch and then dash something. It's a git branch dash D. Okay, perfect. That's why I assumed, but I wanted to make sure. Oh shoot, what happened? The branch T set is not fully merged. Hello? If you want lines, you might actually like ST. The cool thing with Magit is you can select any port with your cursor and interact with it with Git. In that sense, it's a GUI. I see. No, Andre's hacking in your machine to trick you. You can do comment allow NC so that you don't need to add anything. Oh, I should have read the chat. The person wrote that under failed attempts to delete branch. Oh yeah, I'm so stupid. Wait, I'm so. Wait. No. Wait, no, it's supposed to be dash D. To delete the local branch, use the following. Is an alias for delete, which only deletes the branch if it has already been fully merged. Oh, okay, so we need to do with a capital D version. Perfect. Reset. And then in the log, I think we have that commit. So I think it's gonna do git reset of the head by 1. Probably hard. I want it. And then log it again. Perfect. Great. All right, let's see. This is like it looks like on a big repo. Damn, let's see. Let's take a look. Let's take a look at this. Oh, it's a video. They had to do a video. Damn. Oh wait, what? Andrew Krivsky. Did you create this? Wait, huh? ASCII-NEMA.org? What is this? Wait, now I'm intrigued. Record and share your terminal sessions the simple way. What? This session feels like it's showing a caveman the modern world. Wow, pretty good. Wait, let's see what is this. So what does it look like? Oh, you cloned the entire Zig repository. Oh, wait, that's pretty. Oh, I guess that's enough for like my use case, right? I don't have like such a bad, not bad, but like my situation is not that many branches and so on. Um, Interesting. Yeah. This. Da, da, da. Oh, never mind. Looks like it was correct. Did you push? You should push. Oh, you're right. We haven't pushed yet. You haven't pushed yet. You did push. Yo, perfect. Oh wait, no, we did push. No, no. I don't think we pushed. Okay, it's not a video. It's recording of terminal. Yeah, ASCII-NEMA is awesome. You can also select text. Oh, you mean it's like? Oh, you didn't mean that as a joke. It's not a video. Oh, what the hell? Keyword shortcuts. Shift, jump to the previous next marker, step back, toggle full screen mode. Huh. Oh, these are the video controls. Wow. I wonder what... It is a fun use case though, right? To implement a video that is actually not a video, but just terminal. Interesting. Wow. Oh, using Ghosty. Pretty good. My eyes. Okay. VS Code has a visual thing for Git too. Look at the branch, look in tab. Yeah, 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 yeah. I know, but for some reason, I've always thought of this guy as the enemy. Like, I'm not sure why. I should use it more often. Um, yeah, I feel it's stupid that I haven't used this. I feel it's like a very useful tool. Um, it's super useful for quick demos and bug reports. I imagine as Kinema. Yeah, good instinct to be honest. Why? LOL. I don't, I don't know. I don't know. Like maybe because of when I was very little and I was like trying to learn Git and whatnot. Um, like this was the way I saw it like on tutorials and I couldn't understand it, so then I just left it and um yeah. Your stream lags when you open. So yeah, that's a problem we've had with the stream where usually um oh my god. Guys, like yesterday the first 2 hours of the stream yesterday, I was extremely sad because I wasn't able to stream since the kbps, which is like the speed at which I upload video or like the network connection, whatever, was going up and down, up and down, up and down, and it would be through the floor. If you look at like the VOD um from that stream, you'll see it's like me lagging incredibly. That's why one of the VODs is called like we might have fixed OBS. It's because we had that problem. And every time I would open VS Code, it would drop from like 6,000 kbps to like 237. It would be absolutely insane. I didn't know what was happening, but yeah, it seems like a lot of load. Um, I have been influenced by this idea, that like trying out NeoVim, like the cool kids do nowadays. Um, I have the problem that I never really learned how to type on a keyboard. So when I type, I don't actually do like the hand movements that you're supposed to. I sort of developed my own typing where like it is not ideal. Um, it is not ideal, and so I don't think I it would be wise to use NeoVim before I learn how to type correctly. But it is an idea, a good idea to entertain. Um, it lacks when you resize the left panel, I imagine. I can use it by default, but it uses 4 tabs and the spaces between lines is not right, lol. Let's check your typing. I mean, I can type like when it comes to speed, like not that bad. Like you've seen me coding as like I'm a little bit slow, but like not that slow. Um, but if it's like words on the screen, I need to look down at the keyboard in like I feel like after typing like this for so many years, I developed like the need to simply like look for a split second and then know like where the keys are. And sometimes I just stare at the keyboard. I don't know, but press any key to focus. Let's try this out. Um, Although I've been learning, I've been trying to learn through keybr.com. It's like such a nice website. I like try to not look and then like nine real learn line linen area r right. So that's not looking, but if I try to look, it's like real well such still may they. However, so you see, I'm kind of slow. Never here in one. However, can begin what give must to into little have develop change. Ah, change send down like very could could. Yeah, that's miserable. 70 words. Well, it's not miserable, but it's little compared to the potential I could unlock if I didn't have to look at the keyboard. Um, so yeah, yeah. I'm constantly looking at the keyboard since I have to know because these are random words. when you're coding, you like I know what I want to write, so I just look at the keyboard and write it. Um, I don't have to switch between the two. But yeah, I don't know how I got to be like a programmer, um, like typing like that. Uh, cool website indeed. Yeah, I don't have keys shown on keyboard, so it's useless to see. Use KBR when adjusting to that keyword. Oh, pretty good. Um, but what do you mean you don't have keys shown on your keyboard? I feel you said that way too calmly. What? Yeah. Okay. Cool website indeed. Yeah. Surprisingly fast considering you're constantly looking at the keyboard. Yeah. Well, thank you. It's like the consolation prize, I guess. Um, always looking at the keyboard seems so miserable to have to do. Yeah. Yeah. It's like I wish I could, because I feel like one of the advantages of typing is rather than the speed, you subtract that mental toll that processing the information of what key do I have to press next takes on you. So now you can sort of be more well rested mentally. I'm not sure because like after an entire day of like it's like a little piece of your activity that consumes like a tiny piece of mental effort to always be like, okay, let's press here, let's press here. If that can be automated away, that'd be pretty cool. Plus, I'd be pretty fast. So I'm trying to learn. I'm trying to learn. Currently, my speed without looking, it's like 30 words per minute. So definitely not there. Um, yeah, and I imagine it would be more comfortable because you would just need to spend your time like thinking of what you want to write, and then it just happens. So that'd be pretty good. Like they're blank keycaps. Why would you buy such a keyboard? Question mark. Like, well, I guess so. I guess that yeah, if you develop sort of the instinct to know where everything is, then sure you don't need it. Uh, once again, this is like presenting like modern era to a caveman where I cannot really conceive a keyboard without the keys. Perhaps because like I've lived with keys all my life and like I rely on looking at them. It is miserable experience though to switch between two of such keywords, which I have. They have a little bit different layout. I imagine like 8 years of muscle memory kicking in the moment you're trying to actually write something. It's very funny. Yeah. Oh, hello to the new people in the stream. We're coding a memory allocator, but right now we're just chilling a little. Um, you know, feel like we haven't talked that much, during the memory allocator coding. We've just been like creating all of the code. So this is nice. Um, and yeah, yeah. So I imagine like the muscle memory really kicks in when you need to switch. I would wonder why you would need to switch between keyboards. Maybe between like a laptop and then like your actual keyboard. My PC has a membrane keyboard. I stopped spending money on keyboards. Oh, pretty good. So, are the membrane keyboards like the ones that you like roll? The ones that are like, the ones that you can like do this and then like roll them up and then put it in your bag and take it everywhere. Um, those are kind of cool. I have one at work and one at, oh, okay, 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 okay. That makes sense. That makes sense. That makes sense. Um, yeah, honestly, I've been I don't know if you can guys see my keyboard. My keyboard is like this guy. Like I have it like wait. One of the cables is stuck. There you go. This is the my keyboard. Very nice. Yeah. I have it like illuminated blue for some reason. But can you believe I got it? I got it for free. I got this keyboard for free. Somebody was like giving it away. Like they were like they posted like, oh, I don't need this keyboard anymore. I didn't have a keyboard immediately. Where do I have to go? And he was a very nice guy, and then he gave me the keyboard. So now we have a keyboard, and I'm happy because I've never had like a mechanical keyboard, and it sounds very nice. So yeah, The member keyboard has a capacitive switch, not a mechanical one. Oh, okay. So it's just like the type of keyboard. It sucks, but my custom keyboard broke, and since then I decided not to spend money on this. Oh, you had a custom keyboard, dude. No, I feel like I would get really sad if it was like if you had your custom keyboard and then like all of a sudden it break. $450. Okay, that must have hurt then, like a lot. But I guess it's like it's also the sentimental part, right? That like you get attached to your keyboard. Like it is my keyboard. Like designed it. It's so. Let's see. PCB is broke. It was a flawed design. It was a prototype. What is a prototyping? Is that the brand? Prototype. Okay, yeah. I see, I see. It was a prototype. Oh, dude, so sad. That's sad. That's sad. Man, you know, unfortunate. But yeah, I mean, drink some water to stay hydrated. Keyboard enthusiasts will waste money on anything if it looks flashy. Mm, yeah, I mean, it depends on like the type of keyboard enthusiast. I feel like if you want to have like a good it makes sense to spend like a considerable amount of money on your keyboard if it is something that like you design kind of like what Arctic did, where, like you choose it and then you're like I'm gonna I intend for this to last a long time. um yeah, no, that's why you build your own keyboard. It's cheaper. I'm not. I don't know about keyboards, guys. I don't think I kind of have to take what you said face value. Well, I could have made a custom but commercially built keyboard. It would have been cheaper. I see. Wait, Arctic, so wait, do you mean that the keyboard that you have, the one that broke, um, did you like do it yourself and like created it from scratch? That'd be insane. Like I don't know. That'd be pretty crazy. Uh, I'm going to build a dactyl maniform. It will be fun. What is it? Neg Vorsa, yo, hello. Kika, soldering. Let's see. Dactyl maniform. What is dactyl maniform? Oh, like a split one? Whoa. Okay. Dude, this is like the kind of thing some Neovim wizard would be using. That like you abstract yourself to, use. Damn, that's pretty cool. Yeah, they have like a pretty. I guess it's for the hands, right? Like the position of your hands, and that's why they have it like that. But it's interesting. Wow. Keycat soldering. What does that mean? Is Keycat a oh schematic capture and PCB design so far? Hmm. Let's see. Mine was a free word take EL, by the way. Let's see. Free bird take EL. Oh, wait. Do they allow you to like have your own kid? That's such a good idea for like a company. Ooh. So these keyboards look nice. They look very nice. Now I know what I'm gonna do the first, like when I get a full-time job. If I get a full-time job. you know, this first thing we're acquiring people. We're acquiring a keyboard and I'm learning how to type. And then after that we're gonna have enhanced streams. So yeah, um, pretty good, pretty good. Let's see. Is that flexible PCB? No, there's usually no PCB. You usually have to hand wire. Hand wire. Don't buy this, by the way. Okay, okay. I mean, you already mentioned that like it was a prototype and so on. I don't understand TKL. Why would you willingly give up extra keys you could use for all kinds of activities? I would suggest you get a key cron. Okay, the controller in some corner, I guess. What is a key cron? Key cron? Oh, I've seen this once. I've seen like at least the colors, right? Where the it's like red and same for the interesting custom mechanical keywords. Oh, you can just customize it. It's just that the style that people choose is usually that one. Oh, whoa! What is this thing? Why is it split so weirdly? Oh, can you just merge them together with magnets? Oh, that's fun. Wait, that's interesting, anyways. Damn. Yeah. This is like these are goals. These are career goals. So eventually we'll get there. Um, let's see. There's usually no PCB. I would suggest you get a keychron. Okay, the controller is in some corner areas. It doesn't use as much desk space. Yeah, like this one has a numpad, and it's like a little bit difficult to work with the mouse. Although I like to use the numpad sometimes. Yeah, you can customize this. They have layers, so you can have a lot of virtual keys, but you don't need to move fingers as much. Oh, okay. Yeah, because so layers, I imagine, of course, like if you press Alt and then like etc. 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 and then other keys. That'd be pretty fun. It's more ergonomic apparently. Those are cheap. It's like $50 for a bare bones kit. Are you talking about the TKL ones? Or the because yours cost at 450 or the Keychron. I imagine it's the TKL ones. Maybe? Question mark? We'll see. TKL. Where was the name of the brand? I'm looking at the chat right now. Freebird TKL. Let's see. Freebird TKL price. 75% on kids. What? Recession indicator right there. Okay. Um, 199. Oh, that's the. Oh, what? Okay, maybe it was not the tequila. Wait, trying to see. Mine was with key flips and switches because I got like some crazy shit which was a mistake. 75% is the size of the keyboard low. Oh, well. So let's see. Oh, hello, Konosuba Life. Thank you for chiming in. Dude, we have 17 viewers and we're not even coding. Okay, I maybe should dedicate myself to to just hosting conversations with you guys. Like, because immediately after we start coding, it's like, attention span drops by by 90%. Let's see. I love my Glove 80 and Kinesis Advanced 360, but those are pre-built Ergo keyboards. Glove 80. Is that like the in the form of a hand? I imagine maybe. Sounds like it, no? It's like, yeah. So it's one of those two. Interesting. Glove 80. I feel like what this illustrates is like, I feel like you're way more experienced than I thought before. Um, you're like like expert software engineers. Um, let's see. And the Kinesis Advanced 360, but those are pre-built Ergo keyboards. What is the Kinesis 360? Why is it called 360? Is it like a circle? Oh, okay. This is just the same mode as apparently. Okay, I guess it's just the name. Um, it's really good. I'm using 60% right now, but it feels too big. 60% keyboard. How does that feel too big? This is what? You make this smaller and you lose the ability to use like half of the English alphabet. Uh, this is the most minimalistic keyboard you could have, no? Can you go? That's a nice question. Like, can you go smaller? How about a 50% keyboard? Oh, sorry. This is 0% keyboard. 50% keyboard. What? How? Okay, what are you including here? Meta alt raise. Oh, you lose a bunch of special symbols. Um, I guess 60% is the limit. And it definitely seemed like it because, dude, how can you have such a minimalistic keyboard? Dang. Yeah, the one I have right now is like 100% keyboard. So it's a little bit clunky. But for regular keyboards, I use a Leopold FC Konosuba. Like, do you have um are you just keyboard man? Like you mentioned 3 keyboards up until this point. Like, do you have 3 keyboards? Do you use them for like specific occasions or something like that? Um oh, this one looks nice. I feel like I like the keyboards that look kind of like, you know, the Keychron one. They look like very simple. Um like kind of like a typewriter. Those are fine. Are fun. Um Tactile maniform you can 3D print to your particular hands. Damn. The 75% Vector has a daughter board for the USB port, and it's recessed under the case, which means it's near impossible to destroy the port. Wow. My issue is my port got ripped off the PCB on the TKL version. No. Dude, this is so sad. Bro discovering the crazy world of custom keyboards. No, literally, like I knew custom keywords existed, right? Never really bothered to look them up. Yeah, I'm going to build my own ultra minimal keyboard and then just use layers to have access to all the keys. Yeah, that as a person that has to look at the keyboard in order to type, like that definitely sounds like the goal being to minimize finger movement. It's so funny that like the more you progress through that hierarchy, the you know you're gonna end up with like the 0 keyboard that we accidentally looked up, the 0 keyboard. Um, where you just like mentally transmit whatever you want to type. Um, oh, look at this one. Oh, he didn't even bother with the case. He just put the entire controller. This okay, this feels like weirdly functional. Seems like you have the keys that you need. You have enough layers to the point that you can access the other symbols that you lose. Yeah, pretty good. Um, Kono, you say I use the Glove 80 at home and Kinesis Advanced at work. Ah, I see. Ultra foldable keyboard, bro. I don't know what to expect from this link. This is gonna show me the most. Okay, this one seems normal. This one, I thought you were gonna send the link to some like random keyboard that would like fold in the shape of like a donut or like a circle or something like that. Pretty good. Yeah. Oh wait, this is very cheap. Well, like very cheap in comparison to the prices we've been seeing. This is like $65. Dang. Wow. I'm not allowed to use Bluetooth keyboards at work. What? Gonna. Um, what? I feel like you just similar to Andrew. I mean, like you just dropped that fact like it was nothing. But what do you mean you're not allowed to use Bluetooth keyboards at work? Do you work for like the government? Like some like super critical infrastructure that they just don't want to have Bluetooth at all. That seems like a little extreme. Then I need a regular keyboard for other people to use my computer. Oh, okay, that makes sense. That makes sense. I love the 40% keyboard. No way, there's. I thought 60 was the limit. Was 40 the one that I just showed? 40 keyboard? Keyboard. Oh, yeah, I think it is. Oh, wait, did you see that one? They put like little stickers on their keys. Wait, this one. $79. Okay, $80. That's more of a normal price now. This one has like stickers on the keys. Huh. Pretty good. Let's see. I just want to look at the images. Um, yeah, I think it's similar to the one I just showed. Pretty good. Can we go lower? Do we have 30 keyboard? We do, but it becomes at that point it's a little. What happened to the A? What? Where is the Q? Okay, yeah, I see the problem now. So the smaller you go, I imagine this is what um uh lazy schemer wants to do. Hey, who was the one that mentioned yeah, lazy schemer. You were the one that mentioned that you wanted to minimize finger movement. Um, and Computer Havoc, welcome to the stream. Uh, we were coding a memory allocator, but we diverged to this conversation, and it is very fun to do this actually. No one is allowed to use my computer. Wait, Nick Vorsa, do you mean that like as in a personal stance? Like, oh, no one is allowed to use my computer, or like quite literally? Like at work, nobody is allowed to use my computer. Um, let's see. What is this one? What is this one? Oh, this is the kit. $50. Wow. Interesting. I imagine they don't have uh the keycaps and all of that, right? Nor the switches. Oh wow, it's pretty good. What is this guy? Um this like white wheel. Is it for the volume or something like that? Or is it like a joystick? Maybe they have a side view. No, they don't have a side view. Oh wait, it disappeared. Oh, it seems like just a random extra key. Okay, maybe a Vietnam, yeah. Okay. Um, let's see. But if I had to choose one, I would just use the Glove 80 for everything. It's by far my favorite. That one looked pretty nice. It's out of scope, but this is real good value. Um, yeah, Keychron is a good company. Pretty good, pretty good. Okay, Nick Borsa, you shared a Google link. I'm going to trust you with the link. Imagine immediately get banned from Twitch. Uh, Embedded system engineer. Ooh. Oh wait, what? Is it just this? Like, do you just don't have keys? You just like press something in like a plate, and then like, ba ba. Wow. Oh, look at this one. This is like a little card. Yeah, this one. Yeah, this one goes a little too far. But yeah. Security issue. I do not do anything crazy, They're just overcautious. Okay, I see. If you're crazy enough, you can go to steno keyboards. No, I imagine it's like a steganographer or something like that. Uh, that would actually be insane. Are they selling steganography keyboards for? No way. They're actually selling steganography keyboards. Wait, no, no, no. No, no, sorry. Steganography is the action of hiding a message inside plain sight. So when you do uh, encryption with the bits of an image, as an example, um, right? Steganography is yes, steganography is that, and then I always have trouble differentiating them. Hmm, let's just look it up. What is the name of the people that write super fast in court? Stenographer. There you go. It's not steganographer, it's stenographer. So like a stenograph or a stenographer. Yeah, it's court reporter. Dang, they're selling those to normal people. And they're barely moving their hands. Absolutely insane. I think this is the words per minute. So 150 words per minute. Would this be viable to write code though? Like, is it I'm not sure if this makes sense to write code. This is a meme who needs A anyway. Oh wait, I think I'm looking at like outdated messages. Wait, sorry. I'm being a little slow. Um, security issue. Blah, 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 blah. Unfollowed. This is a meme. Oh yeah, I have a steno keyboard, but I haven't spent much time learning steno. What do you mean you have a steno keyboard? Would not get anything smaller than 75%. Yeah. It's out of stock. That's out of stock. That's the only problem. You can get switches and caps cheap. Rotary encoder. Touch. Oh, okay. That's what the controller was for. That Keychron keyboard is better than even 200 gaming keyboards. Lol. There are Emacs users who use foot pedals. Stenography. Yeah, thank you. It's all about chords, probably not, and syllables. I imagine. Um, yeah. This was a very interesting session, guys. Like, this is pretty good. Um, wait, was this like serious or was he joking? If you're a real man, you'd get rid of all of the vowels. You are weak. Same people. Okay. I see. Okay. Bro, I might order one right now. Yeah. I feel like as I said, it's gonna be one of my goals. I'm gonna just have to investigate about keyboards and like really learn about them and then like buy like a very good keyboard. I feel I would do that once I learn how to type because I don't think it's wise to spend a lot on something that you cannot really appreciate. And that would be my case. I cannot really appreciate a good keyboard if I always have to be looking down. Um, but yeah, this looks great for the price. Let's see. Oh wow, I agree. It does look nice. Oh, and it has like switch. Ooh, knob design. Why do keyboards have knobs now? What is the intention of knob? Like, I imagine you slide it and stuff, but like, is it just another layer? Is it like controlling the layer you're in? And so now it's not a key, which is a discrete value, it's like contiguous, and then you can define intervals in between. Um, use lot cur use lot cur. Oh, are you referencing the Reddit post where it was like, if you're a real man, you don't use vowels? Yeah, 8 key full rate pre-built foot pedal brother. Brother, what is this? um, for volume or anything you want. Okay. It's like replacement for the touchpad. Tiffany Pirate, hello, welcome to the chat. What? I feel this kind of like I would be a little concerned if I saw myself in the need to buy the foot pedal. Not like because it means that you're fast enough to the point that the foot pedal makes sense. Or that like you are so intertwined with your keyboard to the point that like using your feet is now something you consider to be sane. So I don't know. It's kind of fun. Oh, the Japanese URL custom issues. Oh, what do you mean? Did you try to send the Japanese URL and then it wouldn't let you? Oh no. Wait. Yeah, let's see. For CNC machine. What is a CNC machine? Computer numerical controller refers to motorist computer automated tools that interpret digital instructions to carve or shape materials such as. Oh, okay, I see. Oh, I don't know about this. Yeah, it definitely looks like one of them. Like, dude, this has been all over the place. First, it was like, what is scoped comments? Well, first, guys, we were supposed to write the memory. I said I'm going to bed 1 hour ago. And then now we're like diverging. I honestly like it. Like, don't, like, you're not priving me for any sleep. Um, I feel like I enjoy this a lot. But we were coding the memory allocator. Then it was like, oh, what is scoped comments? What is jujutsu? Then we looked at, and then we started talking about the keywords. But yeah, it's very fun. Um, I do wonder, like, just like as a last question, can you write code with a stenography keyboard? Stenography for programming. Coding JavaScript with a mechanical steno machine. Two of the evils of the world. The steno machine and JavaScript. I think Plover is probably your best. Oh, I thought it was a video. Um, oh, whoa, whoa, whoa. No, this is the one that we're looking for. This seems like a video.
JavaScript FizzBuzz using some ES 2015 features. So this is need strict mode from node. We'll make a function named FizzBuzz that takes a start and an
Brother
end.
of mine. What? The words just like appear.
This is just going to be a generator function, hence the asterisk.
Yeah. You can we can probably be just as fast with like autocomplete and stuff. That is a great point. Yeah, you lose the autocomplete thing. Interesting.
It's going to be the string portion of the fizz. If
I thought he was gonna like write it like super fast. It seems like they're also thinking about the problem. Pretty good. Intro to stenography coding. It reaches a level of commitment that I'm not sure if I'll be able to get there. I imagine you'd spend more time learning the key combos than you save in a lifetime by typing faster. Yeah, I feel the same, right? Like it gets to the point where like the amount of knowledge and like muscle memory you have to acquire is so big that it may not be worth. Nah, you only need to learn for a year or two. Huh? Do you not what? A year or two? Bro. As the reason these keywords are fast is that you type them not by letter but by syllable combination. So it makes sense why the whole world appears at once, or at least I assume it works this way. Oh, okay, that makes sense. But how much code are you gonna write to offset the year or two of learning the same? Yeah, that was like my same thought process. Uh, I guess so. Yeah, maybe after a lifetime it pays off. But damn, that's I feel it's interesting to know that there is a world of possibilities. Right? Like I don't think I will ever get there, but it's good to know that if you ever wanted to get there, you could. Right? So there's possibilities, there's people out there that are interested in it. Um Companies that are creating all of the products. So that's pretty good. Um yeah, it's pretty interesting. Oh wait, I missed the message of a new person, I think. Oh no, it was just Tiffany Pirate saying oh. Let's see. So let's switch to workspace 3 and copy this one. Oh, these are like the keycaps? What are they? Also, can you just, is that a thing? Like, can you just replace? Well, I guess you can replace. So, like, I've seen with like, once again, I've never had like one of these keyboards. So, I'm new to a mechanical keyboard. Like, you can take the keys off. I imagine if you make like the key have the same sort of model where it has like the little cross, you can just replace them. Um, but like, do all the keyboards have the same interface where all of the keys have the little cross? If so, that's pretty cool. Because then it means that it's one of the few things that as humanity we have been able to agree on. We couldn't agree on the interface for operating systems. We couldn't agree on the interface for drivers and stuff like that. And then we agree on what the keys should be. Um, it's cute, right? I don't even need to memorize the key layout. Yeah, it doesn't matter. Wait. Was the thing you okay? Because the way you're speaking right now. Oh, okay. I was scared that what you shared was an actual keyboard. I got like five keys and then just smashed together. Okay. Yeah, no, I agree. It is cute. Pretty good. And let's see. It doesn't matter once you. Oh wait. It doesn't matter once you blink a LED. The next level of enjoyment is to build your keyboard and never use it. Yeah, pretty good. I mean, ah, dude, there's so much stuff. Okay, I feel like I'm reaching a. Oh my god, 19 viewers. Dude, how do we have so many people watching the stream? Okay, this is. Dude, it's so funny that like on one side, um, coding a memory allocator, da, and then it's always like, um, it's Nick Vorsa, Andrew, what was the name? I forget the specifics of the name. It's Nick Vorsa, Andrew, and Sync Strickneed. There you go, Strickneed, and ZM usually joins too. It's only us. And then we start talking about all of this stuff, and then more people join. I guess it's more accessible, right? And it also makes sense because, it's not very entertaining to watch like a random guy code like a memory allocator. Um, I feel like coding is better when you do it yourself, right? And um, I imagine like, especially Nick Borsa and Andrew, like looking at the mistakes I make, like raging at the screen, like, bro, no, that is not the way. So yeah, let's see. Sometimes I like watching keyword making videos on YouTube. Pretty good. Well, now I see why a lot of big streamers don't code much. Yeah, like in the coding space, um, the reference I have is the Primogen. I really like the Primogen, and like it is kind of the reason why I started streaming, because I didn't realize that you could actually, stream coding sessions. But yeah, I noticed that like usually he just does like vlog readings and like articles and stuff like that and converses with people, which now makes sense. I feel like I really like this sort of format where you just like have a conversation about programming and keyboards and all this stuff. Um, I feel like an exception to the rule may be sorting. I don't know if that's the way you pronounce the name. T sorting, sorting. Um, great guy, great guy. I really like him too. He does a little bit more of the coding, and it is sort of what I had as a reference. Like, oh, gotta code something. Mr. Sosin. I don't know who is Mr. Sosin. Mr. Sosin. Oh wait, is that his name? Mr. Sosin. Back in college 20 years ago, I learned how to do. Wait. AI cannot replace him. Oh, Mr. Sozin. So is Mr. Sozin like? Do people usually refer to him as Mr. Sozin, or to Sodding? Like which one of the two are used in the midst of the React devs? Oh, that's his name. I see. Mr. Sosin. Mr. Sosin. Okay, now I know. Because I was like, how do people pronounce sodding, right? I guess you just say sodding, but yeah, interesting. Um, interesting. But yeah, I see the streams and it's like magical. It's like, yeah. He refers to himself as Sosin. Wait, that's his IRL name? No, I'm checking you. Oh, is that not his name? So his name is some cryptic text of Cyrillic, which I don't know how to pronounce. It's his beatboxer name. What do you mean it's his beatboxing name? Um, you're referring to the popular meme and greeting. Hello, everyone, and welcome to yet another recreational programming session with Mr. What? I know that hello everyone, welcome to yet another recreational programming session, right? I didn't know I had never heard the Mr. Sozin part. I guess I'm not like I haven't like seen as many streams as sorting can sound like Sozin. You see. I see. Oh, you have a video. Let's see. Let's take a look at the video. Bean. Oh, did he? He's actually kind of good. Okay, what is the context of this? Hello from Moscow, ML, my comrade. He just used recursive beatboxing function, bro. What is this? Is the video all of this? Like, did he just beatbox once and then just people started like, bro, what is this? Moscow ML is a standard ML compiler. Oh, ML is in like the OCaml, modern language thing. Or like, I imagine that's what you meant because machine learning wouldn't make much sense here. Moscow ML. Oh, so it's an actual. Oh, sorry. I thought he. I don't know where he's from. He does kind of like an accent, and so I thought it was saying like "Hello from Moscow, hi comrade." Russia. Oh, okay. So it does make sense, but not sure from Moscow, but Russia makes sense. Wow, pretty good. Mother Russia. Yeah. I see. Interesting, but yeah, like he is the sort of one of the only ones that I have identified like does coding a lot. Um, yeah, I kind of love it. Strangely, Twitch is still not blocked in Russia, so he can still stream. Oh, that's a great observation. Why is Twitch not banned in Russia? Uh, that's interesting. I mean, I guess you could have a workaround, right? He could still stream, like just like, through other means. I don't know, a VPN or something like that. Um, interesting. Coding a UI in C to piss off the React apps. That's one of the. Do you know Jasper? He does C program streams too and gets hundreds of viewers. No, I don't know Jasper. I am extremely new to the world of like streaming. As I said, I just started 1 week ago, and I just said like, oh, let's do it, right? Mainly as a means to learn, to have people to learn with, and to hold myself accountable. And like, nah, we gotta, we have an audience, and we have to turn on the stream today, and we have to learn today, instead of rotting in bed and like just not doing anything. Um, Jasper, is it Twitch? Twitch. Jasper with an E. Jasper Twitch coding. Maybe we can put it like this. Seems like I cannot find it. Oh, Y for Spur. I see. Y for Spur Twitch. Oh, Y for Spur. What is this? Custom tooling, designing an instruction set architecture and building from scratch tools like assemblers. Dude, this is. Oh, this is ideal. I feel like I would enjoy these streams a lot. Do we have some videos? Clips? Oh. Oh, no VODs. Okay. Low-level programmer, reverse engineer, electronics engineer, HPC engineer, cryptography and cybersecurity. Started coding in the 90s. I can code in assembly. What? C, C++, Rust, etc. Wow. It really does help with accountability. I tried streaming one time and progress was pretty good even on one viewer. Not sure how it would work in long run because you can just not code and talk all the stream. I feel that that's a jab at what we're doing right now. Um, yeah, we currently just whoa. Let's see. Workstation. Oh, is this a description of his entire setup? Design and taped out circuits. An Emacs user, I see. Enjoy engaging with chat questions and do my best to avoid the trust me, bro, I'm an expert. By offering real examples and showing peer-reviewed references. The difference between the novice and the master is that the master has failed more times than the novice has tried. Wait, this is a pretty good phrase. Oh, Paul Lerdo. Oh, let's go. When they ask you, what is the purpose of life? Proof and conjecture, and keep DSF score low. The game with DSF is defined as follows. If you commit a wrong, DSF gains at least 2 points. If you fail to do something good that you could have done, DSF gains at least 1 point. And if you simply remain neutral, if you're okay, no points are awarded. The goal is to keep DSF score low. SF stands for the Supreme Fascist. Damn. C programming, Article 1, what every programmer should know about performance, profiling, benchmarking. Oh, interesting. Article in Scrib, build Monad. What? This is incredible. Wow. I feel like I would enjoy this. Like I dream of the day I get to that level of professional and of knowledge. Um, but yeah, Jasper. Wow, pretty good, pretty good. But yeah, excellent. Wait, why do the people? Why are all the people different? Like, this is one guy. This is like another person. This is the same person. This is now a different person. Are they all under the name Jasper? I am really confused. Okay, that's um interesting. Okay, but yeah. I feel like I digress. But yeah, wait, this is very fun. I need to explore more the world of like code streamers. Um, let's see. Anime mentioned Pog. He doesn't show his scam. Oh, okay. That's his side, the code path. Hmm. Let's take a look. Whoa. Yeah, you know it's gonna be good when the website looks like this. This document is meant as a guide for seekers of deep computer science and engineering. Oh, wait. With an inner desire to explore the infinite depths of the computing world to gain clear understanding and mastery of computing. I feel this aims at a specific kind of person. Uh which I guess it's all of us, but yeah, that's pretty good. Only one instance of the code path? There's a plethora of other projects that can be added, and others that can be expanded far beyond what's described or proposed here. Enjoy. Wow. Let's see, what are these? Write a C program that returns the sum of the two. Oh, we're starting from scratch. Uh, Write a C program that reads a text file and returns the frequency of occurrence of its ASCII characters. Okay. Write a C program that looks up a value within the binary tree described above and generates a dot file with a colored path to the node representing the given value. If the value is not found, the program must generate an uncolored binary tree. Write a C program that generates an image representing the Mandelbrot set in the PPM or PNG format. Wow. I'm gonna run analyze and optimize the performance of all the previous codes for x86. You must perform handmade performance analysis using call get time or RDTCS. What? Design and implement LVM and GCC instrumentation plugins. I feel this is not only the code path, but the path of like 10 years. Because this is absolutely insane. Like getting to level 6 could probably take like years. Years. I've stopped using Discord. I decided to host my own server on my Raspberry Pi, and I do my guys. Guys, what? This it is the quintessential like master level programming. No, where I feel like you mentioned this before, no? Like the more you progress in the programming world, the more you're inclined to the more skeptical you are in a sense. Um, Perhaps because, experienced programmers are more aware, or because they're not only do they not right, they have the tools to create something that's more efficient and that adapts to yourself. I've also seen a lot of people concerned over privacy and stuff like that, which I would certainly be in the current era. But it's fine. I'm like, I host my own server on my Raspberry Pi. Um, you can read the article. It's all about summing numbers in an array. Yeah. PNG format would be hard. PPM is easy peasy on lifetime. I'll run my own Git server as well. Yeah. I think, Arctic, you were the one that mentioned this, and that's where I first made the comment. Um, yeah. Dude, this is absolutely insane. Pretty good. Okay. Look at where we are. It's like 12 a.m. now. It's midnight. So I do have to go now because um unfortunately um the real world is waiting for us, and then I gotta wake up in the morning and go to the job or like the internship or whatever. Wish I could stay here, honestly. Finish the memory allocator once and for all. Um yeah, we should start thinking about other projects too. because once the memory allocator is done, we need to move to something else. Have been thinking about some things. I want to learn Rust too, and also Zig. So maybe we can think of something like that. But I feel like I'm getting ahead of myself. First, let's finish the memory allocator, and once we do that, we're actually going to go down the path and like actually say like, okay, what's the next step? Right? Um, Creating like the underlying infrastructure for sockets seems pretty cool too. Uh, the world is our oyster, so we're gonna we'll figure that out once it happens. Coders are crazy. You have good energy. Oh, thank you so much. I mean, knowing that it's midnight, yeah, I'm surprised I'm still so awake. Zig is greater than Rust. Interesting. I don't know any of the two. Cannot really tell you. I have seen though that Rust, the more you advance, it becomes a little bit like C++'s like template hell. I've also heard a lot of people say that async in Rust is really bad, whereas Sig really thought through their async model and it's very, very good and easy to use. It's cool that you're running your own Git server. Honestly, for personal projects, I think it's the best way to go. Now you're tempting me. Maybe in some stream, I'm gonna enter and then I'm gonna say, guys, we have our Git server. Blink lead in Rust. What is blink lead in Rust? I'm so sorry, Wei. I don't understand what this message means. Real and based. Like, I mean positive and motivating. Oh, thank you so much, dude. Thank you. Zig devs, I know what they're doing. Async is just a bad model. It doesn't work well in any language. I guess so, yeah. Rust is slow and kind of bloated, seems like. Interesting. Like, slow at like runtime or compile time? Because I've heard people complain a lot about compiling time. Oh, slow iteration. Yeah. Okay. Development cycle, etc. I see. Um, yeah. The macros are weird. Yeah. The fact I saw like a little bit of Rust, and the fact that print was actually not a function. It was like some sort of weird macro. In that moment I was like, why are we doing it this way? Although I'm interested to know sort of like the explore the borrow checker and all of that stuff. Um, let's see. Oh wait, you explained what you meant by LED. Blink LED in Rust. Oh, I see what you mean. Like making a little LED blink in Rust. Yeah. So don't blink any LED and never enter the rabbit hole. I see. Hard coded into the compiler. But yeah, you should definitely learn Rust if you have time. Declarative macros are fine. Procedural macros are weird, but you can get really far without ever needing them. I'm so sorry. I feel like I don't know the difference. Perhaps part of my inexperience. Um, procedural, procedural versus okay. This is gonna be one of the versus declarative macros. Macros. What? Okay. Explain like M5. Thank you so much. Declarative macros are simpler to use for simple tasks once you're familiar with the syntax, but less powerful. If you've ever written a web application, they're like HTML templates, but for Rust code. They're Rust code with extra markers that say insert argument here or repeat this part for each argument. Oh, something like LaTeX, I imagine, in the math world. Maybe. Procedural macros are more powerful, but there's a certain amount of minimum work that you have to do, no matter how simple your task, because they're full-blown programs that run inside the compiler. Wow. What? A procedural macro is a program which will receive Rust code and must modify it however it wants and then return it. But does it return Rust code or does it return something else? I'll need to see a link to where it says macro rules will be deprecated, but I assume it's because they plan to make a better replacement for it. Interesting. Um, Let's see, let's see, let's see. Maybe like LED, like a diode blinky program or microcontroller. Yeah. Micros are weird. Print is actually hard coded into the compiler. Comp time is cool in Zig. Learning Rust was definitely useful, even though I switched to Zig later. Interesting. I still prefer C though, it's weird. I think coding streamers really need an app where you can preload your code, and then as you type anything on your keyboard, it automatically types or deletes the code for you from scratch. It's like a supersonic coding showcase too. I think. Wait. Let me read it again. I think coding streamers really need an app where you can preload your code, and then as you type anything on your keyboard, it automatically types or deletes the code for you from scratch. Oh, okay. Something like to be able to showcase your code. Something like there is. I'm trying to remember. Where have I seen a concept like that? Not for code, but oh, I know, dude. When I was a kid, dude, I'm 20, not that far from a kid, but um, when I was like little, I remember watching a bunch of Minecraft videos because I really liked Minecraft, and there's like this system that they have where it displays like a layout of what you want to build, and then you just follow the layout. So something similar. That's actually a pretty good idea, right? If you want to showcase code, right? Like here what I like to do on the stream is like to think together with you guys because sometimes if we were to rely only on my thinking, we would be, you know, we would be in a really bad position right now. So Zig is quite low level. Sometimes I feel like it's lower than C. Interesting. It must return valid Rust code. Oh, okay. So that's what the macro does. Basically, it's just like a compile time function, I think. Okay, that makes sense. Maybe function is not the right word. I mean, sure, but I understand, yeah. Play with the token in the syntax tree. What? I think coding streamers really need a Primaginal. Yeah. You're using C++ for this? Oh, hi, Ben. No, we're using C. We're coding the memory allocator in C. Currently, we're just having a chat because we finished malloc, our implementation of malloc, and we're all very happy. So that's that. Um, let's see. That's how you. That's just how streaming is, right? Yeah, yeah. You can build a Twitch extension which shows info about your project for desktop users. Huh? Wait. What do you mean? Insane. Congrats on the progress so far. Thank you so much. Yeah, we've been coding a lot. This started 1 week ago, like on Saturday, the last Saturday. And yeah, it's been a long journey. We had the C++ code for red black trees, and then we had to sort of translate it to C because we needed it to behave a little different. And now we're here in the memory allocator, the nitty gritty of it. So it's very, very fun. Um, this streamer is having overlay where you can see the current inventory. Oh, current inventory? What do you mean? Let's see. Oh. No. Okay, let's see. What do you mean by the Twitch extension? Oh, the stream is about the lag. Is it this guy? Slay the relics? Display Slay the Spire run info on your stream. Oh, you can build what? Wait. So which one is the overlay? This is so Oh, what? Oh wait, I can like interact with it. Oh, dude, that'd be so cool. Cause then gain 2 energy, potion slot. And if we click the map, wow. Dude, coding something like this would be kind of fun, yeah. it would be pretty fun. Although I think maybe there's already an extension for it because I imagine it's a need that a lot of people have. Um, see, it shows like wide rectangles on stream. Yeah, like press button left rectangle. Wait, let me. Oh shoot, no, no, shoot. Wait, I sent it to the T. Okay, let me send this to 3, and then let me open back again. There you go. Bottom left rectangle. Okay, let's wait for it to load again. Um, yeah. Like these guys, these wide rectangles. Question is like, how do you even connect this with the game? Oh, what? Close draw pile. Ooh, dude, I feel sorry for the Twitch developers that had to implement the functionality for extensions because that seems so. Yeah. Um, what stats would it even show about coding? Maybe the task. That's a good question, right? Like it is like maybe that something doesn't have much use for us right now, but it would be interesting to think about it to see like you know overlay that connects to your IDE and shows symbol hover information from the language of dude, that would be a pretty good idea. Probably a security nightmare though. Yeah. Okay. I don't feel I am as experienced to do something like that. Um, I feel if I were to get into maybe something like NeoVim and stuff like that, where you can actually set up your entire thing and like learn more about LSPs and so on. Um, but yeah, it is an interesting scenario to consider though, right? To like have in mind. Um, yeah, wait, let me bookmark this guy because I'm also gonna need this in the future. Um, yeah, yeah. Oh, here we have the contiguous and physical memory function. Uh, yeah, this article. I don't know, but yeah. Yeah. All right, guys. Okay, it's 12:14 a.m. and I haven't eaten dinner yet, so I also need to eat dinner. Um, Probably gonna eat soon. You know, well, soon. I'm hungry. I'm hungry. So, and then after that, I gotta go to sleep. But this was a very nice session. I feel very happy. I don't know. I feel like after I get out of like that office, coming here is like something I look forward to. So yeah, I'm glad you guys hang out. That everyone is here. Thank you guys for being here. Like you're the ones that make this very entertaining. And yeah, to all the new people, thank you very much for joining. I hope you enjoyed. If you have any ideas for the future, let me know, right? And yeah, I don't know. So for privacy and tagging, you could use Fetchable, a web server, and comment changes to it automatically when a task is done. That would probably be easy to integrate. Ooh, pretty cool. See you. All right, guys. Bye bye. I'll see you in the next stream. And yeah, thank you so much for joining. Bye bye. Whee!